Right. Here we are. Camera's behaving. My monitors are back on the right side again so that the streaming thingy can figure out where to put. Oh, I didn't update the details about the stream. Well, that's on me, I guess. Where's the oops, and there's some audio playing through here. There we go. So we are not actually working on Domino UI. We are gonna do some template work. There we go. So I'm trying to get this back going again, because it's a cool project, and I like the idea, and we're close. We're really close. We've got a lot of the details right. We think we've got potential to make things actually work. I just haven't had time to get back to this to get things done. I spent a little time this morning working on other projects. I've got some of the Eclipse plugin work that we had last time around working. That's behaving a little better now. We got the server up for it. In other words, we've got a version deployed there to try it out. And once we've got that piece going, we can release a new plugin in the marketplace, and Eclipse users can try it out. I am not an Eclipse user, as you can see. This is all IntelliJ. Going to be sticking with that for the foreseeable future. But there are people who prefer that, and this will make their lives easier. So that's what we're going to do. Yeah. I also spent a little bit of time. We tried this last week. I don't want to spend more time on it right now because it's kind of a headache to iterate through this work here. But here is the tooling that's going to rewrite the JS enum type, or the annotation in GWT to work in GWT2 instead of just in Jackal. And the basic idea is that you stick an enum on one of these things and it will generate a package. This will end up being just a plain old object in JavaScript with a bunch of properties in it. Each of these contains a number, or is assigned to a number. And then from JavaScript, you can say plain JS enum.0, and you actually get the number 0. Obviously, that's not very helpful. It would be something like this, where none equals 0 and unit equals 1. And it allows your JavaScript users to reference these things without them being full objects, and they can actually pass in the value if they need to. They can serialize them to JSON easily as necessary. And if you need them to be other values, there's the feature where your JS enum can have a... I've got them commented out right now. They can have a has custom value where you can pass a number other than a long, a string or a Boolean into this value, and then that will represent the value in plain JavaScript. That way you could have some of these, true and false enums, and then they can pass numbers in. You can have, switch case where there's defaults for other values you don't recognize, and it would correctly be able to handle that. If you had only support for certain numbers, you could just have those numbers caught here, and then default would just assume, hey, any other number just falls through here and breaks. And then you can go further and say, okay, there's a custom value. It's a string, but I didn't define it. Some external JS library I'm working with defined these values. And so let's model that as an enum within Java, because I can't be bothered to remember all these string constants, so let's make them out to be enums instead. And then you don't have to worry about, okay, is the string being passed into you capitalized or not? You just got access directly to it as an enum. So and that's covered later on. I don't have that piece working yet. I do have custom values working for everything except Booleans. I don't have Slack muted. Let me mute it over here too before it gets too annoying. Yeah. Don't have the native enums working yet either, and that would look like... maybe I don't even have them in this test. Anyway, this giant test class is pulled in from... oh, I know what I did wrong. There we go. It's case sensitive right now. So we can say, hey, there's some enum that's defined in the JavaScript itself in this namespace with this name. And what this actually does is it is a model to say, hey, reference the stuff that we've already built. Oh, actually, this one isn't. This one I build out by actually defining some JSON and saying, hey, in window.test.nativeEnum, there are these strings attached, because some JavaScript library did that for me. In this case, I just need some simple setup to make it work. But once we have that, we can now reference those enums here from our Java and use them. So this is not working yet very much. I've got the basics in place for it, but I don't have all the important pieces. It's a lot of little changes across the code base, and then it's about, looks like 400 lines, 350 lines of setup here to say we need to be careful about some certain methods you've got. There are a lot of things you can't do in JS-enum. Let's see here if I can pull up what the enum actually says over here in the Jackal code base. I was taking a look at how it's actually written. Here we are. So they've got a couple limitations. You can't use name, you can't use values. Ordinal, you can sometimes use. Also value of, you can't use. They don't document that, but it doesn't work either. And it turns out your enums, whether they're native or not, do not extend from enum as far as JavaScript is concerned. Because of course these are just going to be, you know, the number 10 or the number 20. They're not going to be real objects. So you can't as easily do instance of, or you can, except the enum class has final members. So if we look at how enum is supposed to be emulated, it's supposed to have a final name and a final ordinal, but we want ordinal to sometimes throw, and we want name to never work. So we'd have to unfinal those things to make them work. And I am suddenly worried that I left a burner on upstairs in the kitchen, so I'm going to go and poke that real quick, because I can smell burning from down here. Let's go and do that real fast before anything bad happens. Nothing's burning. I turned it off before I came downstairs, as I was supposed to. I guess the fan in the house just suddenly kicked on and I could smell it. Anyway, yeah, so these they already exist, they're final. We don't want them to be exposed to the browser, so we change the type inheritance of these classes to say, hey, don't use this. And we actually warn, or we error out if you ever try to reference them, even though Java would let you do it. Yeah, so that feature is probably 70% ready. There is a discussion point added on the Jackal code base to say, hey, let's can we understand why you made some of the particular design decisions. There's some weirdness around comparable. For example, if you have a custom value, we don't apparently support comparable. Even though those values should be comparable with each other. I don't understand why that's the case. This is also wrong. This chart is wrong. There should be an X here according to the code and the tests, so that native JS enums are comparable, but I don't understand why those would be comparable if other customized value types are not. So I don't follow that yet. I'm trying to figure that out. And there's a few other restrictions that seem confusing to me, or at least should be documented in the annotation itself out in JS interop annotations. And then I'd like to remove this. This is only supported in Jackal because it is not hard for GWT to support it, at least with these constraints. And then we just have to decide, do we want the same constraints in Jackal that we do in GWT? We're going to have to figure that out. Okay, so that is the catch-up I've been doing on other stuff. I am trying to get back to this. I'm going to do just a quick, hey, here's stuff that sort of kind of makes sense. You know, committing all of these changes that currently exist. And then once all this is checked in, I'm just going to say, okay, let's start going through the processor and figuring out how to go from this document format that we've described here. You know, what is a document, or what is a tag? What is a DOM element versus a component element? their respective contents, how their references work. There's a few pieces we haven't actually wired up yet, but we have an idea that says, based on, you know, some details like this in your Java class, especially with Java 17 with these triple quotes, we should be able to say, okay, take this HTML and then rewrite it to roughly this Java here. And we've got a good idea of what that Java should look like. We've got ideas of how to handle nested contents like this, where something needs to loop over a collection, and how that lambda will get put together. And whether it's a lambda or a separate method, it's really not important. We've got some tools here, like this has scope to say, hey, take a lambda and automatically run that lambda several times. Let's see, the lambda actually gets run. Let's see, where is it? There's the reference, there's the unbound. Unbound fragment is our interface that will say, given this value, bind it to a document fragment and return the fragment. That way the caller, who we will see here, can say, hey, give me this fragment, and then it will grab all of the contents of that fragment and stick it in whatever it's doing. I don't quite remember why we've got first child, last child. This might be just a context quirk to say, hey, keep track of, within this document, there's a bunch of top-level elements, and any given node could span from here to here, and there could be other nodes between them. So let's make sure that all of those nodes actually get put together properly. All right. Okay, so let me just make sure there's nothing else to be checked in. Looks like there's a fair bit of other stuff. If I just do git add dot, am I going to be fine? Make sure it doesn't pick up target directory stuff. I guess if we got a good git ignore, because other stuff is not getting grabbed. I don't imagine that all this compiles right now. Let's just give it a quick try and see what it thinks. It doesn't want to use, oh, we need to use 17. So let's set up 17 and try again. Okay, cool. It actually all compiles at this point. So that's a relatively decent check-in point to stop with. Why are you dragging? Please just leave it where I had it. Thank you. Right, so we defined, just from the start, to refamiliarize myself and you, we have defined a template annotation that has a value. We've got some ideas about style and selector. Justin has separately pursued styling to say, here is a language which allows further templating. We have notions of subcomponents to say, I'm going to reference as a tag these other components, please bind them accordingly. And in order to reference them by name, we use this this annotation, for example, here to say, I'm going to say phone number view, and then you can see we actually reference phone number view here and here. And that allows the template system to say, here is the name of that thing here. Now, if we get collisions, we're going to have trouble. I'm not really going to worry about collisions right now. We may get to that point. It's hard to describe that using annotations without doing nested annotations. Then we also have bindings. And a binding is a, one moment. Right now, we're not really sure if we're calling them bindings or directives. We're trying to take different bits of advice out of existing tools. Anyway, got to decide on a name for this. A directive is pretty simple, just saying, hey, I've got some data and I've got some DOM element. The generated code is responsible for making sure this is called often enough, as is appropriate. And then has scope is the same idea, except there is a new scope introduced, where instead of just the bean, the model that's being passed in, there might be some new binding that has to get tracked. So instead of doing a VDOM idea, if you're familiar with React and the like, we are saying we are going to do all the work at compile time to figure out exactly what changed. From your perspective, you should just write templates, and these templates, you can behave as if they will fully re-render every time. But they're actually not going to do that. We want to completely sidestep the performance problems of VDOMs by just doing direct DOM manipulation. And that means you can do other things, manipulating the DOM directly technically. We're going to advise strongly you not do that since you don't know when it's going to re-render things, but instead you interact directly with the view model. And the view model represents the data that is actually existing here. So for example, this is a view, this implements view, and it will have a DOM element, which just means it'll expose some DOM element, which we'll get to in just a minute. The view then has a view model of some kind, and there's a setter for it and a getter for it, and the code gen is responsible for populating that too. And if we look at the subclass of this, the manually generated subclass of this, we've got a bind call here, I guess, and a setter. I think set will call bind as well as keep a copy of it. Anyway, the view model has some restrictions in how it's written. It's not a bean. Instead, it is a bunch of properties. And very likely we can generate these also, but we haven't done that work yet. These properties are the work that Justin has done. Say, how do we make things observable? How do we make it so that this thing here has a bunch of properties that are each themselves observable? And how do we do the more interesting things like nesting observable things? Do we need an actual object property wrapper for this? I meant a wrap. Let's do that. Do I need an object property wrapper to detect when it's reassigned? Or do we just say, nope, there's only one thing, but its sub-properties might be reassigned? So I think we want to allow ourselves the flexibility to say that either one of these notations should be legal. So we say new object property. Can I initialize this? Let's see. I can. Oops, not an object property. I want recipient view model. There we go. So we'll comment that out for right now because I'm going to just stick with this approach. But I think we want to support this approach also. And then instead of a list directly, we have to have an observable list. And we also want to have the ability to detect if the list is swapped out. So this is using the other approach. This and this are the same approach. But an observable list is a list. It extends the list, but then it adds specific hooks to make it observable. And then I guess we've got some other utility methods for keeping track of stuff being added and removed. But the important thing is that listeners will get a change listener, which will say, hey, some list change happened. The list changed is added and changed and removed elements, and we can detect those from whatever code happens to be worried about. Your own application code could do that, but more likely it's going to be something in here to say this UL here needs to get new LIs automatically added when new things are added. We need to correctly remove them when elements are removed. And if an element is swapped out, we need to replace an LI with a new one. And if an object's properties have changed, for example, the skew property changes, then only this little bit of the DOM here should get rewritten. So never mind how all those details are being implemented, but everything will interact on this DOM element, which is very close to how the browser itself looks. I anticipate we'll be able to say JS type on this interface, and give it a name and a namespace just to say, hey, here's a plain old element that exists somewhere already in the browser. It's going to have a factory of some kind. This is going to look a lot like document.createElement. It's going to expose all the details about it. Its tag name, reading and writing attributes, finding and replacing children, and extends from DOM node, which adds quite a few more other properties here too. The only implementation I have today for testing purposes is a string implementation, where we've got some simple factory that behaves, again, like document. You can do create element, create text node, create document fragment, create attribute, and those things will respectively have some way that they keep track of. Apparently my internet is out. Still, it's been out for an hour, according to the text messages I keep getting. I don't know how to tell them, actually it's fine. What are you worried about here? It should have been fixed 20 minutes ago. And they are saying it will be resolved as soon as possible. Anyway, internet seems to be working. Looks like the internet can see me from here. Am I here? I seem to be seeing myself stream in my quick test page here. I can see things. There we go. All right, it's working. Anyway, this is a string-only implementation which has the handy feature of toString, which will iterate through attributes and children recursively and write things out. It does not handle self-closing tags properly. So for example, if you tried to write an image with an src equals blah, and you wanted to be self-closing like that, instead it's going to, let me just copy that, it'll be easier. It will instead first make one and then do this, which is probably okay. I know there's some oddities in the browser around the script tag that they must never be self-closing. I think the browser is pretty much going to be okay with having a closing tag later on. Because the problem is we need a registry by tag name to say what is permitted to be self-closing and what is not. That way we know when to put contents in. So that's something we'll worry about at a later date. But the point is, we can toString this, so as we build our test code, we can just say, hey, I want you to take this model here, I want you to bind it to this view, and then show me what the HTML is. And then hypothetically, you could put in a VDOM downstream of this and just generate HTML snapshot strings and say, okay, VDOM this, and then VDOM this, and then detect the diff and apply it to the page. So this implementation, as it is, coupled with a VDOM, would be a complete solution on the order of what React can do. But given that we've already modeled this as a plain DOM element, I think we can go further and say that it actually returns, it actually directly manipulates the DOM when things change. So we'll figure out how that goes. This is wrong, clearly. You should not clone node by returning null. Doesn't look like anybody calls this yet, so we're probably off the hook. String DOM element parent dot clone deep. Oh, that is going to break, actually. Yeah, that's not going to work. And this is defined here. Clone node calls clone node. This is just a Java override thing because JavaScript just assumes certain properties like that. Let's see. I think these other ones are, that one works. We are almost certainly going to need this, so I'm gonna pause here and go ahead and build this. Yeah, it's just DOM element that's broken. Okay, we need an implementation that works for this. The constructor here takes a tag name, so we can just copy that across, and then copy across all the children. We are going to need not to override this, so we don't need to build this twice. And we're going to need to pay attention to, do we clone deeply? And let's take a quick look at the documentation in the browser for what a deep clone would be. Pulling up some documentation to browse here. Okay. It returns a duplicate of this node on which the method was called. Its parameter controls the subtree is contained, whether it's cloned or not. Cloning a node copies its attributes and their values, including intrinsic or inline listeners. It does not copy event listeners using add event listener. So that's a problem we've actually encountered, because if you want to add listeners in one place, you have to, every time it gets cloned, add another one. So if you have a single line, that's cool. You can just say, okay, every time I clone you, I'll reattach your listeners. But if you have a panel which does some work, and then outside of that panel, there's something else that needs to render that panel multiple times, now we have a problem. We need to be able to call back into the original rendering code and say, hey, I know you already attached event listeners, but I need you to reattach them now. If true, and then the node in its whole subtree, including text, is copied. If false, only the node will be copied. The subtree is not cloned. So does that mean it's moved, or does that mean it is just ignored? So let's take this node here. Let's see what's inside. Do we have more children? We got a tag, and we've got some HTML. So let's take this, which is going to be referred to in the console as $0. As soon as I'm able to get this resized. There we go. Okay. So we got $0, which is our p tag. And if we do clone node true, then we get clone equals We've got children. Child nodes is 3 things, but children is only 1 thing. It doesn't see the other things. So children must be HTML elements. Child nodes must be nodes. If, on the other hand, we say false, now we have, sorry, it's not p, it's clone. Child nodes is empty, and children is empty. Okay, so it just simply doesn't copy them. It's a question of, do you only copy attributes, or do you also copy child nodes? All right, let's move back over here, and we'll say string DOM element. Copy with its tag name. We'll iterate through our attributes and copy them also. Let's do something like get attributes. Sure, attribute names. I guess we could just straight up clone the underlying attribute. Map. We'll say name value. And then we will say clone.set attribute. But it doesn't let us add an attribute node. What do you do with string attribute objects? Once you've got one, who can manipulate these? So if I have a bound attribute, I can create an attribute, and I can say what? How do I actually attach that attribute to where it belongs? Did we not do this properly? We've got to have a... Let's see, this is my code. I'm the one who screwed this up if there's a problem here. Attribute set value. And then where does it actually need to append it to? We get the data out of this. Nothing calls this, I guess. Maybe I have screwed up here. String DOM element is going to read the values out. Set attribute will append it. Get attribute node will grab the node itself. Yeah. I don't know how this works, which is why we're back and going to probably spend some solid quality time on this in the near future. Trying to get the hang of this. Yeah, no, this doesn't seem sane because it returns the attribute, but it doesn't use it. So this must just be a utility class I wrote to say, hey, this will make sense, and then I never actually put it to use. This is the only thing that calls it. Okay, so this might not make sense. How are we supposed to use attributes? Let's look at element. There's a get attribute. There's also a get attribute node. Has attribute. Get, has, remove, set attribute node. So that must be the one that adds the attribute node itself to say, hey, I want to hold a reference to their attribute itself so that rather than modifying or replacing the attribute in the element, I can modify the attribute node itself. Set attribute node takes an attribute and adds it. Okay, so let's just make sure that it exists in DOM element. Get attribute node. It just doesn't exist. Okay. All right, so we're going to need to implement that also. This exists on element itself. Yep. And then we'll need to build this out. If it already exists, then the attribute is replaced with a new one, and the replaced one is returned, the old one. So I guess this returns attribute. Let's go to set attribute node, or get attribute node, and then we'll override here set attribute node, which will return attributes dot put attribute dot get name attribute, and fortunately the map itself should replace it. Oh, we'll just cast that because that has to always work. Otherwise, you've done something cheaty, like created DOM nodes and string nodes and tried to mix and match them. So attributes, then the put method of map, the underlying Java map, will just go ahead and return the old one that used to be there, so that you get a reference to that. This method is seldom used, blah, blah. That's fine. Okay. Very likely we need to implement that, but not our problem today. Okay, so for each attribute, we're going to say set attribute node value, and then if deep we'll do a for I here because it's slightly quicker in GWT to do this. String text node, abstract string. Do we not have an abstract string type here? No, we'll just have to cast it, I guess. And then we'll say clone dot end the children as we get them. Now we do have this nice append overload that takes a whole bunch of DOM elements. We could just turn it into an array there. This will be less allocations here, but it'll be more allocations when we get to here. So I'm not really going to worry about it right now. That should be pretty close to what we want. We'll make things more efficient later. But this is especially going to run on the server, so I'm not really concerned about JavaScript itself. Which means I could replace this with just a regular for each loop, but not going to do that right now. Okay. Okay, so we have clone node work, or clone node working, so that we can call it from, hey, I've got a fragment, I need the fragment to be cloned, and cloning fragments is how we're going to worry about sub-elements. So fragment, let's look at fragment real quick, because there's some funniness around here. Document fragment. There's a little note in here, as I recall, about using this. Performance is often overstated. In some engines, using a document fragment is slower than appending to the document in a loop. However, the difference is so marginal, it's better to optimize for readability. Okay. Well, we're probably more worried about performance than readability. Usage notes, the common use is to assemble a DOM subtree and then append or insert the fragment into the DOM using node interfaces. Doing this moves the document fragments in the DOM, leaving behind an empty document fragment. So that's important because it means that the handlers will still be attached, the event listeners. This interface is also of great use with web components. A template contains a document fragment. An empty document fragment can be created with this. So somewhere in here we hit the note about, hey, it's gonna lose all your event handlers. Let's just search real quick for I think that's what we already looked at, this first one here. So let's take a look at the Stack Overflow comments. This is 8 years old. This is useless. Oh, Stack Overflow, what do we do with you? Yep, not at all what the person's asking. Is it possible to attach a click? Click event will not work in this case because the document fragment is not appended to the structure. So you can't edit the fragment itself. That makes sense. The solution is to attach the listener to one of the children of the container. Okay, that'll be fine as long as you don't clone. Often you don't have a direct reference, like you're working with templates and clone node. In many cases, the fragment only contains one element, so first child is a good way to go. If your fragment were more complex, you might need to use query selector, but the problem is as soon as you do that with clone node, it's going to take it all away. Second, when you call append child, they are moved into the DOM. Fragment doesn't contain a reference. The idea is that a node can't have two parents. This means by the time you call add event listener, there aren't nodes for the events to happen to. That's fine. But it still doesn't cover the clone problem. They just say, this is what's going to happen here. Avoiding the document fragment pitfall. This is the snippet I was looking for when I started this point here. It's not a valid target for its events. So we add the click handler to the clone of the template's contents. Result, the first clone is a document fragment instance. So when it gets appended inside the document as expected, clicking on it does not trigger the click event. So just to recap here, the first clone is a document fragment instance, but clone node of content is a document fragment? Yes, of course it is, because it's not each of the children. So instead what we need to do is clone the first child. No, that's still not what I was thinking about. I don't want to add handlers to those. We haven't solved the event handler problem at all yet. We've sort of got a model for how that might look, but cloning nodes is going to break all this. Okay, well, let's come back later. We'll figure that out then. And of course, with strings, there's no handlers anyway. We don't have event handlers if you're just rendering strings. All right. Okay, so we have all these ways we can build and we can use elements at runtime. It's going to be a different implementation on the server if we ever get that far, or building whole strings of HTML and then relying on a VDOM. We also, because we implement the same approximate API, can just delegate to the browser itself and say, hey, browser, just use your own DOM manipulation and make it go fast. So the next piece is going up a step and saying, if we have this nice little language we built, which allows us to implement a view in a string like this, how do we parse out these tags and figure out how to call attributes, call set tab position, because on tab panel, we have a tab position, which you can call set on. And in fact, we have an example where we say set value to top. And this is the corresponding bit of Java we would expect to see generated from this attribute here. And likewise, when you change these things here, these attributes here, they are called on the correct attribute of the component. So notice capitalized, right? So that's our convention for capitalized. On the other hand, if you have an HTML tag like a label with a 4 on it, we would expect to have a label here, and I didn't go ahead and actually attach the 4. So let's do that real quick here. Here's the first one with 4 phone. Let's make a single one here to say I never actually built this part of the DOM. Obviously, we need the code gen to do this for us. So now we say label for phone needs a set attribute of for phone. This isn't dynamic, so we don't need to worry about this changing when the data model changes, because it's just static here. If it had curly braces in here of some kind, we might need to do something else about that. It doesn't. And then we need to append some text here. So label for phone dot append phone. Okay, so now this one is correct. This one here is already built because it's a more complex model. We just insert the DOM element here. I didn't do the other label, and we have this ampersand just to try and break things, make life a little more difficult for future me. And I guess we didn't do the recipient view here. I guess we don't have a recipient view accessible here. I never built it. So, in theory, you'd have a recipient view that will do something with this. I see recipient view model. Nope. Never did it. Okay. So the parser's going to puke on that eventually. Today, we have a language defined here, which says all the different properties and things we need to worry about here. We define what does it mean to have XML, HTML tokens. How do we worry about entities? Because entities are kind of a mess of various ways you can encode things like that ampersand. How do you correctly tell the browser what you're doing there? What are you mad about me here? Expression okay, it just took a moment. I have done a little bit of cheating here when I defined this part of the spec to say how do we handle tokens in various cases. You're not usually supposed to use these. These are called what? Contexts? States. Lexical states. Very likely the language could be cleaner and not need this. However, it seems to be a pretty complete language right now, so I'm not going to worry about it. These are basically simple regular expressions that say when you're parsing this particular next couple of characters you see, here's how you should parse it. And then once we get further on here is where we are looking at the actual structure, which is more complex than what a regular expression can handle. So if you've seen the Zalgo HTML stack overflow post, which is a classic to say, hey, you should not, oh, that's not what we want. I don't want something about how does it work. I want the actual original post. Maybe they link it here. Nope, nope. Nobody actually links the original post. Is this the original? Yeah, okay, so basically saying, I need a regular expression that does this. And somebody gives this fun, silly answer about how it doesn't work. And eventually you go crazy as you read the thing and the text starts falling apart. Anyway, you can't use HTML. You can't use regular expressions to parse HTML. That's the important part. Instead, we use a pushdown automata. That is the technical name for how we are saying that, hey, we've got things that are happening. We've got various matching states here. We've got, instead of just one state that we iterate through as we build this thing, which is what a finite state machine or a regular expression or however else you want to specifically define the actual bit of computing that's happening as we parse your document. Instead, we've got some state to work with here. So we still will process your document relatively efficiently, taking one look at each token as we go through it. But we will need a little bit of memory to keep track of where we are in the document. Are we inside of a tag? Are we inside of a tag inside of a tag? Are we inside of a tag inside of a tag inside of a tag, etc.? So this allows us to say, okay, a tag can either be a DOM element or a component. If it happens to be a DOM element, then we first look for open tag, the name of the tag, potentially some white space, and then some more attributes. Attributes themselves are attribute, potentially some white space, and then more attributes. And then potentially more white space. If it's self-closing, that's the end of that. We're saying it's either going to be this, or the pipe here is this here. It's going to be contents. And as you can see, it says, hey, this is where it gets recursive. So contents now is when we can go back up here, where we could be a tag, and a tag could be a DOM element. And a DOM element can have contents. So this is how the recursion of your structure gets defined. You got a tag at the top, and the tag can have tags, can have tags, can have tags. Your attributes can't have tags. They just are attributes, which are one of three kinds of attributes in our particular language. We said regular attributes, event attributes, and directive attributes. And We also define them twice because we want to treat attributes differently if they are in, this is the wrong file, if they are defined on a component, we define them one way, and if they're on an HTML element, we define them a different way. Just because there's some very slight differences we need to worry about for how we're going to read them and what we're going to do with them. I have elected to make the parser responsible for this, since there's enough context to figure out whether you're setting this on a component, see it's capitalized, or whether you're setting it on an HTML element. It's not capitalized, so we can clearly see that's not what you're doing. So that means if we go to component instead, it's slightly different. We've got a class identifier. We still have attributes. I guess it's not different. I thought I had done this. Maybe not. Maybe I meant to do this and I just didn't do it yet. Only the videos didn't get deleted. I could go back and figure that out. Thank you, Justin, for making sure that doesn't happen again. Although I'm not sure how much video I would sit through to figure out what I planned in the past. Anyway, the component itself has contents, and so you can build other things inside of there. You can have a close tag and your own class identifier. I don't think this is correct to put an HTML identifier in there. I think that's just completely wrong. You don't want parentheses there. And then likewise, this is just a class identifier. And we use this just to make sure that you close with the same tag as you open with. Technically in Java, in HTML, you don't need to close every tag. If it's not self-closing and you know that it can't have contents, you can skip it. But we're in good company by requiring closing components. React, for example, always requires it. It just makes the parsing work a lot easier. Okay, so anyway, we've got all these various things that are going to be generated automatically as part of our build. If we go into, let's see here. Here's one of the generated classes that says, hey, here is a document. Actually, this is not a generated one. I made this by hand. We have a couple of these that way you can build features into them, like what's your tag name, and you can set that tag name from the parser, and as it discovers it, it can expose it here. And then you can actually read that tag name. Here's an example visitor that's going to pick up tag names and try to do useful things with them. So now we're getting into the processor side. Once we have the whole thing parsed, let me crawl up the stack here a little bit, and hypothetically say we've got a template. This is not what I meant. Here we go. We are looking at your code. We find a template annotation. So we say find the template element. We're going to find the actual instance of it on whatever class you're looking at. We're going to read off the HTML string out of the value. And then once we have that, we're going to put it through this parser. So this template language here is generated code, obviously, because I would go nuts writing this, based off of your file here. So all of this here, some 200 lines of, here's exactly what I want the parser to consist of. It's generated into here to about 1,000 lines of this file, and there's a few other files it generates along the way too. See, this is a very simple one, I think, but it's still 400 lines. And then we've got a token. See, token's pretty boring. Token manager, is this the one that's got some real estate in it? Yeah, check out all these switch cases or loops. It is doing its own code generation to say, okay, well, how do I tell what state you're in as you're parsing? And all of this is completely not our problem. So we are never going to spend time digging into here. We might have stack traces that wander through here, but for the most part, we aren't going to read this. We're going to go back to our language and say, something was wrong there when we built it. So we've made some small changes. Let's just go ahead and package it up. Now, there are some errors we're going to need to deal with at some point. Say there is a possibility here where the parser can't understand what you've said, and it could go one of two ways. And this is the kind of thing that's going to cause a headache for future me, but today me is going to say, future me's a chump. He can deal with this problem then. And he hits it. So text node. A text node has HTML characters in it, and apparently there is another possible thing that follows this that could also have HTML characters in it. So let's see, text node is referenced only from here. It's possible that this collides with white space. That seems unlikely. Let's see here. We've said you can't use these tokens, but you can use any token other than these. So I think we have to exclude white space from here too to make this happy. The problem is we want to actually capture white space and just junk it when we find it, except between words and things like that. Between tags, not important. Between words or before or after words, then it's important. So that is future me's problem. I'm not going to care about that today. But the rest of it seems to work. Oh, and we even have tests. So this is just still stuck back in recap. Plain HTML test, we've got some references in there. It's going through and saying, yep, all those work. Let's take a quick look at those real quick. So basically, I went through and said, make sure you can do each one of these and you get something out of it. We haven't verified that the contents necessarily make sense out of this, but if you've got a text reference, yes, that will work. If you've got a text reference nested in an element, that works. Mixed contents, so in other words, we've got strings and DOM and references. Adding with and without white space, just in case that ends up making a difference. And then we have, I expect this to fail because we did not, there was a reference in this tag. I think we can also add an expect to fail if you have tags that don't close properly. This is about references though, so we're not going to put that test in here. The other test we have is just plain HTML to say, hey, all these things will parse correctly. We probably should modify this to say, make sure there's exactly one element, make sure it's a div, make sure it has no attributes, and so on. We expect failure. I wrote this wrong. We need to have two methods of this. One for the first line, one for the second line. There we go. Because each one will separately fail. How do attributes work, and so on. So we've got a lot of very simple cases that only make sure, does it parse at all, not do the contents make sense. All right, so here's where I need to stop talking and start thinking, because we need to get from there all the way over to here, where we actually generate real HTML. And at this time, we have just a very simple bit of code here that does that bookkeeping. It parses it and then says, let's keep track of your directives for some reason. I don't remember what I'm doing here. We grab the document, we visit the document with this template visitor, which will say either there's an element or a component at the top level. And if you find a component, visit it like a component, keep track of your depth for rendering purposes. This is the oops, that's not what I meant to do. Put that back, please. This is the hey render big trees in the logger. To say, yes, I understood that a tab panel has a div in it, and the div has a UL, and the UL has a bound directive on it, and so on and so on and so on. So we will render the depth, and then we log to say, hey, I found something, it's interesting. And then when you visit the attribute, we have to figure out how to write the attribute, where it says, okay, split on dashes, capitalize as you go, and then grab the attribute text or reference, or both, which will right now just log this. Later we'll need to concatenate that, figure out how to handle types and junk like that. And then once you're inside of there, you can switch from a component, because we're looking at components, to building DOM elements. And we switch over to this visitor here, which will then have its own depth. And if you find more components inside the component, we just increase the depth. Probably we should just keep a single reference. There's no reason to deal with this garbage. But that's what it does today. And this generates a very, very simple sort of pseudo-Java UI or appearance here that says, here's what it could look like to generate all this stuff. But none of it actually works. There's not enough code here to make it actually generate real code. We don't build a proper Lambda for the... How do we want this to work? We want the li to be created in this Lambda here. So there's expected to be some lambda passed here, which will hold these contents here. So all this needs to be nested in the lambda. I also see we have bound attribute actually generated here, so maybe we forgot something. Let's go back and see if we can populate that, because I mentioned earlier that I didn't see how that was possible. This is an event, but I don't see an attribute yet that uses our $ curly brace syntax. It said that it found one in the li. No, that's the directive it's binding. There's a click handler. Oh, here we are. It's a different element. Some li somewhere has, hey, go through and grab the class names. I bet it's tab. So tab panel has, in this DOM element, it grabs the class name. So we look at the implementation of this, and we never wrote it. So this is again, future problem. I'm not going to take the time right now and build all of this out. I'm just going to try to get close to valid Java today. Okay, so we've got a language. We've got a basic step here. I think I'm going to start with a new step. Where's that step? HTML template step. Let's rename this to something like toString. Just to say, hey, this is good for demo purposes, but not much else. And then I think I'm going to rename these things here also to say this is toString. And then we'll build a new step. So I have forgotten how to do a lot of this work. We're going to go ahead and steal a little bit out of this to get things started. Up to here. We're just going to steal all of this junk. So here's a real class that we're going to do our work on. We're going to go ahead and bind that to a field. It'll be final. Paste this junk in here, close some curly braces so that it at least roughly compiles. We need to go back over here and remember, what do we return here? I think we just return empty. Say, hey, here's the stuff I couldn't figure out what to do with it. And then basic annotation processor dots is what we implement. Because in theory, you might hit things and say, hey, I can't actually parse this, and you could return it for somebody else. But in our case, any annotation will be useful to us, any HTML annotation. We want this to implement abstract processor, or basic processor. There we go. And then I guess we rename this to env. Okay. Okay, so here's the basic idea. We've got a parser. The parser may or may not contain a document. I'm not quite sure why I didn't assign that right away. Because we need it in a try-catch. And I guess this is the log in here to say, hey, here's what I'm about to print. Here you go. Okay, so we'll put that in there too. Okay, so that's a lot of boilerplate, unfortunately, just to get us to the point of now we have a document, and now we need to start generating things. we need to be a little careful about this because I believe this is all beta. Yeah. Let me see if there's a newer version of this we could pull in, which will make that not a problem. Doesn't look like it. One, two, three. Okay, that's slightly newer. And auto service. One, two, nope. Auto service is not what... They got an error when they search for auto service. Here we are. 101. I can't use the new one because I keep getting errors from it. Right. I don't think this is going to change our beta flag here at all, but it's worth a shot. Oh, I must have misread. 1, 2, 3 could not find auto comment 1, 2, 3. Auto comment 1, 2. Oh, I see. It's somebody else's. JBox Java auto comment. I wonder if they've got a fork where they fix a couple of issues. Because it looks pretty old. Here we go. This again. Thanks, guys. This is a fork and a Gradle build. The Guava dependency is gone. Huh, that could be nice, I guess. Anyway, we're going to put this back the way it was because apparently that's the best we can do. Import, make sure we're happy. What do you want here? Yeah. Okay. I think we're just going to comment that out for right now as we figure this out. And now we need to actually do the work of the boilerplate stuff. How do we generate a class? We need a class in here that will have the contents we're about to build. For that, we need... They should have brought... Should have sent a poet. That's the line, right? Make sure real quick that that's latest. Apparently he's got his own copy too without Guava. Same user. Square up is 113.0. Cool. All right, let's pull that in. Okay, so we did the sort of fun part before, where we actually generate some real-ish looking Java, and now we got to do the boring part where we say, let's emit some... Is this the one I want? Yeah. Let's emit some Java classes. So we say, I've got a template element here. I want to find... Let's see, this is type element directive. What are we going to do with that? I guess we're going to reference that later to look up, hey, are you a directive? What's your generics? The multi-map we're given, there should be some documentation here that gives us an answer here. The readable, please. The implementation of processing logic for the step is guaranteed that the keys in element by annotation will be a subset of the set returned by annotations. Right, so we returned from annotations. I want to know about all templates. The elements will be mapped in here. The elements will be passed back to the step at a later round of processing. Oh, right. If you return any elements, you will get a chance to do them later on. Okay, we're not going to deal with that. So from here, we're saying give me the entries. The annotation is known. We only have one annotation, and it says it's a strict subset. It says it's a strict subset, right? It's guaranteed that it will be a subset. Yeah, okay. I assume that means strict subset. Which means they won't surprise it, add anything else here, which means we can guarantee every single element in there has an annotation template on it, which means we can go ahead and just do this optional thing here and say, just give me the mirror, just give me the element, and then we need to grab more properties out of here. Now, why aren't we using the element.getAnnotation template? Because sometimes, in some cases, it's possible that template wasn't compiled or isn't correct, and you can't actually read stuff off. dot what is it? Get HTML. Yeah. So technically, in this case, that's not a thing we need to worry about here. It is a little more hygienic in general, just to be super careful about that and just say, well, hypothetically, if there is a annotation like that on here, let's just go ahead and test it and make sure we got the right thing. And it does take some extra screwing around like this thing here where you say get value and then turn the value into a string because the value is not actually a string. I don't know if that's important. Where'd my phone go? A second, please. They have preseason one start. All right. We'll figure that out tonight, I guess. Apparently my dinner plans are changing. Okay, so we got a document. It's parsing. At this point, it should be pretty straightforward. We can say, okay, let's do something else to get the document. Maybe we just even push all of this into some other class or some other method and say, look, just give me the document. I don't want all this messing around to get it figured out. Let's see, we're going to print an error. We're going to print it and point at the template mirror. It would be really nice if we could get further in there and say, hey, I've got a line number that's wrong. We're at least going to print the message, so hopefully that'll be enough. But this will be good to revisit and figure that out later. So now we have a document. We also have the type we need to extend from. Template doesn't have documentation on it yet. Necessarily, this must be annotated on an abstract class interface? Question mark? Okay, so our first bit of contractiness here is that we are given an abstract class. So how about just non-final? Technically, we could just take a non-final class. All right. So we want to generate a new type here. We want to say, let's see, Java Poet has a class file creator. What's the Java Poet syntax here? It's been a long time. Let's just open up the jar real quick and see what's in here. Right, so it'll be like method spec and file spec. Probably Java file will end with. We make a builder. The builder needs the package name, which we will get from element.getPackage, right? Maybe. Should be this. It's been a long time. Let's open another annotation process we've got here. I know Jackal has got some. Do they use Java Poet, do you think? This is just what I've got handy, so that's what I'm going to use. It's not in Transpiler, it'll be in JUnit. Where we've got CodeGen for not async. Here we go. This will generate the test suite for a given method. Here's the processing step, which will handle a class, which will handle a class, which will, sure, JUnit 3, test classes.add. Someone eventually has got to iterate through test classes. Oh, good. It's not visible. So this is probably called from the processor that's generated around this. Here? No. It's been a long time since I took this apart to figure out how it works. Okay, so there must be some other way to access this. I see add, but I don't see... Oh, here's writer. Write to test class. Okay, that's what we're doing here. It is going to... Qualified name, open writer, writer.write. Really? That's it? No... Yeah, they just velocity this up. Well, that's kind of gross. I don't want to do that. Let's go look at GoodRPC and how I implemented that. It's also been a long time since I touched this. The endpoint processor is simpler, so we'll look at that. Yeah, it's just a couple of classes. Close everything else, so I can just see this. We implement two different methods, left, right, and right, left. And then we say... Okay, it's longer than I thought. Java Builder, package name. Package name is just... Oh, hey, look at that. There's just a utility for it. But I wrote the utility. Model get package from processing environment. So element utils get package of element get qualified name toString. Nothing can ever be easy with annotation processors. They're just totally allergic to it. Where are we here? So I'm going to put this in the local just in case we need it later on. And then instead of that, it's going to be element. So now we've got the package name. We've got the type spec, which we haven't built yet. It's going to be a class, so we're going to use the class builder here, which is going to be a class name, which is roughly going to be, hey, grab the element, get name, toString plus impl. And I've just done without the underscore for the manually generated one. We'll add an underscore for the generated one, just to say, hey, here's what we're going to make here. So now we've got a Java file builder, which I don't think we actually need to directly use like that. Let's pop back up to here. This is Jackal again. I don't want Jackal. Why are you here again? And it's this. And the package name, and then we just do build write to. Okay, and then you give it the filer. So we say, hey, I'm going to build some stuff. Here's the stuff I'm going to build. Great. Write to env.filer. Okay. And then I guess we got to handle exceptions because sometimes when you write to disk, things blow up. env.messenger, print message. And I think I can say what element I'm after here, but I think we're just going to say the whole type, just in case that is enough use. Can I pass an exception in here? Oops. I don't know if we've got a, hey, please log an actual exception. We don't. So stack traces are just kind of eaten. That's irritating. But at least we got a place to stick a breakpoint when stuff starts breaking. Okay. And I guess we could reference the value too. That'll be nice in the mirror. But still no way to say, hey, there's an error here. Give up. Okay, so now we need a type. We'll put that up here because the type has methods and stuff like that. We want to say, we don't want to actually build it yet. We want to have an intermediate piece here to say, first of all, superclass is going to be superclass or super interface. We're going to assume superclass right now because it's going to make my life easier in the short term. It's going to be the element itself as a type. What else do we need? we want to generate an annotation, which is here, and then we want to add a value of the class name. Something like that. Right? Generated takes a value, we'll stick a date, and I guess we can stick comments on it there too. Not really worried about those things at this time. Okay, so now we've got that, so we can do our own easier bookkeeping later on. Right. This is not good enough, though. We need a type builder instead, and I think we're just going to append on this like this and get rid of the .build call. Because we've got some conditional stuff we want to do here. So for example, we've got is DOM element. Has DOM element? Yeah, has DOM element. We hypothetically could have some other interfaces here like, I don't know right now. We'll figure that out later. Has DOM element. If element is assignable to, we need to be able to say, are you assignable to has DOM element? So it's like types. Is assignable. There we go. We want to know the two types. We want to say the element we're working on versus has DOM element, which we need to make into an actual type mirror. Oh, I forget what it's called. That method we just defined. As DOM element. So we'll say something like type builder dot method. We should probably make a constructor too, right? Because we need to take a factory of some kind that will implement all the various, how do I create elements and junk like that. We may or may not want this bind thing here. Oh yeah, and then we also need to figure out whether it implements view or own view model or view of data. Right now we've got 3 different ways we can implement this. This is what I was really thinking of here. So I think we pretty much assume that we will always implement this, and if you don't, that's a bad thing. So let's just build this out first, just dummy it in real quick. Right now, as DOM element returns a root, and root is just going to be some field. And I think we only assign it once. Oh, it says to do unbind old. So that way you can change this one out, and we will replace the existing one. So that's tomorrow's problem. Let's do type builder, add field. And this is going to be a DOM element, which we haven't provided for ourselves yet. Can I just pass a class in here? I can. This is cheaty. We don't usually like to do this. We'll give it a name root. We'll make it private, but not final, because we want it to be reassigned and rebound. All right. And then our method is not a constructor. We're just going to have it return the field. I guess we do the field afterward, or the what it returns. Element class, and then we just add code. Can we do that? So we have to assume there's no other field called root in here, which is fine, I guess. We need to make this public. Because that's what the interface has on it. It overrides and it just straight up returns the root. Okay, so now we've got a field and we've got a thing here for it. And now this is where we put bind, because if there was some other thing than has DOM element, we'd have a different implementation here that would turn the view model into DOM code. Oh, we should get that factory hooked up too. So I just made a simple little factory for each different thing you can create, and I just wound them all together here. Part of our DOM manipulation. So let's add that as a constructor. Well, again, this assumes we're doing has DOM element, so we'll put it in here. And I guess we need a field for that too. We'll make it final because nothing else can reassign it. I did not know this until recently, but final has some actually importance around fields that will be accessed from multiple threads. So that doesn't apply here because we're running just in the client. But it turns out that around volatile and synchronized and that the like, you don't need a final field to be volatile because it is guaranteed to have its value by the time the constructor returns. You don't have to worry about it not being set cross-thread. But you do have to worry about that for other non-final, non-volatile fields. Okay, we got a constructor. It doesn't need a name. It just gets marked as public, and then it gets an argument. Add parameter. Yeah, okay. And that's going to be our factory. It's going to be called factory. We don't care. Then we add code, which is going to be this.factory equals factory. Okay, so now we can assign that. Let's see here. Now we have access to the factory and we have access to write the root. Now we can write our bind method, which is going to be private for now, but it's going to be part of the setter. There's no reason it has to be that way. That's just what I've decided to do here. So we'll make just a bind method following the same pattern we have here. So when you call set view model, it will call bind. And when you call get view model, it will return the original view model. But if you want to read the root back, you call as DOM. Now there are 3 different interfaces. We just talked about this very briefly. I'll go into a little more now. If it is declared as a view of T, that means the T is a view model. And that means here is the actual view model I'm going to act on. Whenever you change something there and I'm bound to it, I'm going to update my model accordingly. The simpler thing you can do is just to say, here you are your own view model. And as an example of that, we have this tab item, which says, here's my template, which is super, super simple. But then I have my own view model things inside of here. So instead of knowing to call out to another model as a local field, as a local field on the current instance, we just directly access my own fields for these things. So in a template for this, it doesn't exist. In a template for this, it will just call, I guess we need a constructor to do something. We'll put this, yeah, name.get, right? We just access the name like this. But in our example over here, in order to access the actual bound object, we say it's a parameter, order view model dot whatever. So it's a local. We have to access that local, that parameter. I don't think it has to be a local. I think we can just call get view model instead. Kind of like that better. That makes it a little simpler. The implication is then that own view model extend, or is how do you say this? It's generic on itself. Right, recursive generics here. So in this example, it would be tab item. Because now inside of this instead of any kind of generated code, we can call get view model, and we get back, you can see from it right here, it shows you can get back the tab item. The tab item will be returned from there. This makes the code generation easier because you can just always call get view model and be guaranteed you'll get something same back. It's not all about the code generation though. Sometimes it needs to be easy to use, and this is going to irritate people. So let's not irritate people more than is actually necessary. All right, there we go. Okay, so if it is an own view model, we will have to access just on this. Otherwise, it'll be on the get view model. So I think bind is going to take no arguments now. We're going to get rid of this. Every place we would have accessed that will say get view model. Can you figure that out now? Yeah, there we go. I figured it out. And we don't need this. We just say bind. Okay, so it's a private bind. Let's see. Method builder needs a modifier after it. And then we don't need to be override. It's not going to return anything. I don't need to say that. We just need to start adding code. All right, code goes here. The hard part goes here. And this needs to know how do you access your view model. So we're going to have some kind of a view model accessor, because that could be get view model. It could also be this, depending on our cases here. And hand in hand, we need to say, what is your view model type? So that's going to be a type mirror. Declared type? What's the type mirror that says, hey, I'm actually a class instead? Reference type? Declared type. Yeah, okay. We're going to make it a declared type. Just save time for later. View model type needs to equal something. And in the case of here, it's going to be view model type is element itself. Right, because there's nothing else to do. Oh, you're going to cast it, right? We know that that's true. So these are going to be parameters to say, first of all, what do I call to access this? And then second of all, how do I make sure it makes sense? Now, arguably the type checking should be done somewhere else. And we should, before we start writing code, we should say, okay, does this template even make sense? Can we actually work our way in here? I have been having enough writer's block around how to take this next step. So I'm going to do it the hard part, the wrong way. We're just going to do it all at once. We're just going to walk through the template, and as we go, we're going to figure out what type we're looking at that particular stage, and how you access the data so you can bind it. And we're not going to do validation ahead of time. At some future point, if it turns out this has got wheels, got legs, we'll come back and fix that up. But right now, not what we're going to focus on. So we need to test to see what kind of view are we. And actually, instead of doing it instead of here, we should do it up here. Pull this up. I mean, this is the kind of thing here where we should have an enum that lets you say it's either A, B, or C. In our case, it's view of data, view, or own view model. And view of data, how does that work here? What's the difference? Marker interface to indicate that this will directly wrap some bean. A view model may be generated for that type to make it easier to integrate. Okay, so the idea here was instead of having a view model you pass in, we just pass a bean in. And some other magical code gen needs to come in and say, oh, well, I see a bean, I can make a view model out of it. So let's make a note on there that this is not supported today. So not actually supported yet. I think I'm just gonna, unless anybody implements this, no, nobody uses this. I'm just gonna comment it out. That is future us problem. Right now there's 3-ish options. 2 options. 2 chief weapons. What kind of view is this? Right now, 2 options. Own view model or view. Use that to decide how to bind. Okay. Fine. There we go. So if we were building an actual meta model here, there would be a class. The class would have what kind of a view is it? And then it would provide the enum that would provide the 2 options, and then there'd be an accessor which would provide these things here. What's the view model accessor? So get view model accessor, get view model type, which would probably be generated then inside of it. Again, we're not going to mess around with doing it the right way right now. If somebody's interested, we can talk about that in more depth. Otherwise, I'm just going to keep plugging away here. So we need to test if oh, I guess I needed parentheses there, huh? There we go. And that's not the right way to do this. We have to say get type or get element utils dot. It's got a name. This is awful. As type. Okay, there we go. Technically, this does what we asked it to do. We do need to extract the proper generics here. Let's put this here, and we'll split, and we'll split, and we'll move the definitions up. And then we say else if and instead of view, it's own view model. Oops, there we go. Not quite. Close curly brace. So this is just atrocious. So let's make this less miserable because we're going to need to handle the generics of this because view is of course generic on T. So we need to take that T and put it here. To say, okay, you are an implementation of this. What is your generics here? We know what kind of a type to expect down here. as we start emitting all the various lookups. So let's put this element up here as view element. And then we need to remember, how do you pick out the generics here? If something implements an interface, let's go back to our GridRPC code and say if you have an endpoint as parameterization of this type over here. The type here is what am I even doing here? Given your annotated endpoint, find the type that has base class on it. What the hell is base class? Oh, I guess that's how you define the superclass. That way you can say, hey, I'm a remote service servlet. Here's how you're going to implement this. Interesting. I don't remember doing this. But it allows you then to say, hey, I am just a remote service. Here's my remote endpoint that I'm going to work with. Make the generics all fancy and work. Okay. You find a base where base class isn't null. They shouldn't be necessary except for the cast. Okay, well, if it's not necessary, it's probably a bad example to learn from. So let's look at how we build the... Nope, that's the same thing. Find parameterization of, it's just a different implementation of it. Get specified superclass. We've got a remote. We say if the remote is not null and I am a placeholder, then we ignore it. Otherwise, we continue on and we don't use remote as an argument anymore. Instead, we say, let's see here. Take your super type, find the parameterization of... No, this is wrong. This is not chaining. This is just white space because parameterized type name takes a whole bunch of junk here. So it's endpoint element to extra contract name, extra contract type, which allows us to say that your endpoint element, whatever you defined, is going to implement this interface over here. Find out what that parameterization is. It's going to return extra contract type, I guess. So find parameterization is going to say, here's the, oh no, that's the subtype. I'm backward. Endpoint element must be endpoint itself. If this is frustrating for you, I wrote this code and I still can't understand it. This is substituting, no, that's substituting wildcards. We don't want that. We want this one here, where we say flatten out the hierarchy, which we don't need to do because hopefully nobody's building interfaces out of this, but just directly. But we don't know that. We don't know that nobody's going to make an interface out of this. So hypothetically, you could say, instead of making a view, I'm going to make a view interface, and then I'm going to implement the view interface and not add generics there. So we need to actually say, how do I adhere to the view interface so I can detect what T is? So flatten supertype hierarchy will give us all the possible superclasses and super interfaces of the type that we are defining. Wait, is this backward? Look at this. What jerk wrote this? Interface type is the second parameter, subtype is the third parameter. Subtype up here. Yeah, I switched it. We'll come back and fix that. Some jerk wrote this code. Never mind the git blame over here telling us that I guess this Colin guy wrote it. Probably more correct way to find it. It looks like I deliberately swapped it in this patch right here. I did. I just swapped it. I just straight up swapped it. That's awful. Okay, so I'm guessing that it makes it correct only from one single call site. We'll have to figure that out later. Anyway, that's terrible. Flatten supertype hierarchy of the subtype. That's what we want. As you examine each supertype, check to see if the erasure matches the interface type you're worried about. If so, you found it. So that's what this boils down to. So get flattened supertype hierarchy is given a type, add all of the erased types. That doesn't look right to me. Oh no, it's if you haven't already found the same thing with the same erasure. You put it in there. We are tracking by erased name for a key, but our value is the type mirror itself. So we erase and then toString it for the key. So what that means is, as you find your various implemented interfaces, I guess, do you want the more specific ones? Types, direct supertypes. If it equals null, if you haven't seen it yet, then we will add it. And the reason we do it in this order, what is the reason we do it in this order? Is because you want your closer interfaces to be implemented first. So in other words, if my class implements some interface, and I also extend from a class, which extends from a class, which implements an interface, which extends an interface, and that is the same interface, the generics could be different. The closer, more precise one is what we want, because it's assumed it has to be more precise, otherwise Java wouldn't have allowed you to do it. Okay, so we're just gonna steal this method and make it private. And then we are going to say for each supertype, if it's a declared type, check if its erasure matches. If so, you found it. Otherwise, return null. Okay. I'm going to grab the whole thing as is. Remove the comment because at least it's consistent with itself, if not anything else. I'm going to get rid of the static thing because it's just a local private helper, because then we can get rid of this. And just reference environment.getTypes. And likewise, remove this. For the full good experience, allow for nested raw types, because who needs generics anyway? So I think we're just going to say that if you don't have generics, it's not our problem. Dodgy bit here, forcing them to raw. Did I use the word dodgy? Who is this person? Forcing them raw to compare their base types. Is this safe? Actually, yes, it is safe. Answer, probably. We want to check if it's a particular interface, so we pick and return the same interface. That seems to match GWT semantics. Okay. Go me, I guess. So this was very specific to gRPC code. I'm sorry, GWT-RPC code. We are not quite as concerned about that here. We just need to crawl up and find the right parameterization. There's almost certainly a better way to be doing this. Anyway, we're going to need at least 2 different varieties of this, so we'll figure it out later. Let's see, we got a type element, we got a mirror for it as parameterization of, we'll let us say, see, here's the exact method we're going to call. Now we're going to say as parameterization of our subtype, which is the element itself. and the view element interface. There we go. And that means view model type will now be the actual type T that we found there. So in our example, we've got all this fun HTML shoved into Java, and it will find this view and grab the generics here. And it will also handle the more interesting case where you had some T here, which references something up, something. If it is actually generic, if there are generics on here, we actually can't build this at all because we can't tell what type it will be at runtime. So we should probably slap your hand if you try and do that. Let's do a check for that up here. No, I think we're going to be okay with that, because if it is a declared type here, okay, this is actually going to be the parameterized version of view. Yeah, so we need to actually, from there, grab, instead of view order view model, we want to actually grab order view model itself. So now we need to say get type arguments dot get 0, make a separate variable for that, and we need to also validate that this is the right type. If type arg kind declared, what do we got here? What's the kind we could possibly have? There we go. Because it could be a type variable. And that's the most likely bad case. Wildcard is also another bad case. So we will just say if it is a declared type, then we assign, else we will fail out. I probably should have a continue here too, because this is a loop, right? Yeah, that's a loop. Although continue in the very last line is sort of unnecessary. We'll see if we end up with something else later. The cast in here, because we just checked that. This is written with Java 17, so I could use our pattern matching checks, but we're not going to do that here. Let's see here. Else we will do env.filer. Not filer, messenger. Print message. It's going to be our element itself, and we don't need the other details there. We can just say that's wrong. Okay. Okay. We've got an accessor here, we've got an accessor here. It'll just be plain this dot whatever to access the fields we're looking for, and then we've got a view model type, which will be your own type to make sure that that accessor has the right properties. Make sure we're continuing up to the right point. Yes, it'll go up to the top of that loop. Perfect. Okay. So we probably have the right type now. This is really boring, right? I mean, this is why I said we haven't done this up until now. It's the I don't want to do this part until I solve everything else, because this is the writer's blocky, or the other part's the writer's blocky bit. This is the, slog through it and implement the code. Okay, so we have bind written now. We probably want to actually write down which type we used. So let's just make up an enum real quick, so we know how to implement it properly. Probably we'll abstract this out to some other type later. Let's make it, they don't have, Right. We want to have view or own view model with underscores so my content is readable. And then I guess we'll eventually want to have view of data, which won't work yet. All right, this is whiny because it shouldn't be here. Local enums is a language feature we're getting. Cool. Let's just put it somewhere else. I mean, eventually, really, it belongs in an actual model here, but we're gonna be fine. View type. Let's make these final. Jeez. Future me is going to hate this code. Going to come back and say, what on earth is all this? Why is there no meta model? You built all the fields right here. These just need to go into a single class, and your code will be so much easier to read. But instead, I'm a jerk. View type equals... Oh, I can't do a final there. Oh, that'll be fine. That'll be fine. View type equals view. And view type equals own view model. Okay, so now that we actually start processing this and figuring out how to implement it, we will say view type. If view type equals view, if you're a view, you need to implement the view interfaces. Set view model, get view model. So we'll do type builder dot add method spec of set view model. The similarity here is going to be modifier public and annotation override. And we'll duplicate that and do get view model, but they'll have a different body. Get view model be return view model. I guess we need to make a type for this, huh? Or a field for this. We know the type of this. We just put it into a field up here. View model type. Right. Why aren't you happy about that? Might not be initialized. Oh, else throw. Continue with complaining here. Environment.messenger.printMessage error, not element, error. What do we want to call it? Own view model or view. Okay. All right, cannot resolve declared type string. What do you support? Type name. So we're going to say it's not a class name. We need the generic class name. Can we just do class name? Type element, type mirror. Let's make sure this is going to do what we want and actually extract the type args, because it looks like it's going to strip the type args here. Let's see, it's going to visit it, and if you get a primitive, it will return what? Mirror.accept. Visit primitive. Any other primitive than these, it will break, I guess. Oh yeah, I see, and then we've got other things too. Visit declared. If it's a declared type, if it's parameterized, if it's not parameterized, we return the raw type. If it is parameterized, we read the type args. So it looks like that'll work. Let's just make a quick to-do in here. Get view model now needs to return view model type. We now have a, oh, we needed the same thing here for the class name. And then set view model needs to have a parameter, which will be type, comma, view model. And then we do 2 lines of code. First we say this view model equals view model. And then we say bind. And this will call the bind method that we're about to build down here, which is, as noted, the hard part. So we're gonna think about that a little later. Like maybe after lunch. Hey, look at that. It's time to quit for lunch. Oh, too much work to do to get the rest of this done. Sorry. So now we handle the case where view type is own view model, which right now is trivially true. And for own view model, where'd it go? Here it is. We don't have anything extra to build. There's no extra interfaces of any kind. So we don't need extra getter setters. We don't need a field, because we've got a getter that will already work for us. Okay. So now, oh, come on. Am I out of ways to put this off? I mean, I guess I can actually run the thing and make sure it runs. Hey, look at that. Distraction. Let's see if we broke something. It's probably going to be garbage, whatever it comes up with. Oh boy, there is some compiling problems here. Create order form, unsupported view interface. Please use own view model or view. Interesting. I did use view, so that is not behaving properly. That's interesting. I got something backward there. Tab panel impl has an illegal start of expression. Let's see if I can get some. Nope, it's not going to do it. Okay. So I probably needed semicolons or something for that. Let's see, it's in the samples directory. Target, generated, annotations, tab panel. Yeah, okay. Looks like I need explicit semicolons when I generate these. That was not my memory here, but okay. Let's try that. Okay, now it can find them. Illegal start of expression here. Oh, because it needs the better toString or something. Let's see. When we emit generated, what do we say? Why does it put a whole class in? Builder, add member value, class toString. Add member should be a format string. Oh, it should be a format string. Well, that's not going to cut it, is it? Is there another overload I could use instead? Code block or format for an annotation spec builder. Yeah, no, you got to actually just say, hey, here's a string. Stick the thing in there. Fine, whatever. You're a jerk. $L is for literal. And then you pass in the class name. Although the suggestion here was get canonical name instead. Okay. Let's try that. So by using this format string, it's going to say, hey, there's a string inside of this string, so we're going to use it as a literal and make it work. Okay, so now it says, actually escape this contents, put it in here properly. Great. Okay. This one is obviously garbage because it has no bind method, but we have the rest of the pieces roughly wired up. Our create order form apparently doesn't implement view, so I got something wrong there. Let's see here. All I have for this check so far is it assignable? And we failed the assignable check for both of these. And then we hit this else to say unsupported view interface. So it's not the parameterization check that failed. It's the assignable check. Which probably means I just screwed up here what this is. No, that's correct. Is parameterization of... Do I need to be explicit about erasure or something? No, has assignable. Does this need to be explicit about erasure? Let's try env.types. Let's see if that convinces it. Because we are solving for type args here. Yeah, I did it. So now this is the interesting one because it implements order form. It made a field for create for order view model, correct? Wait, this can't be right. This is the this is the one I wrote by hand. Oh boy. Let's try it again. Now, can we regenerate this and try it again? All right, we forgot to make it private. We do have a factory, we do have a root, we do have a view model. The view model is being assigned here, but no new line. That's a little gross. And then it's being returned here. Let's take a look. Guess those must have a new line at the end of them. Just seems silly to me. The code blocks just automatically append new lines then when you add code to them. Code block of. I guess we'll do that. Let's rewrite this. That's a format. I want joining. I don't really want joining. I want multiple lines. I just want to write a couple of lines in here. Let's see if that is what it's looking for. Still no new lines. Huh. And code with positional or relative arguments. Relative arguments map 1 to 1. Mixing is invalid. What new lines? Shouldn't contain braces or new line characters when you do control flow, but I'm actually just doing 2 lines here. W emits a space or a new line depending on the position. This prefers to wrap before 100. I don't remember how you're supposed to do appropriate new lines in here. Let's look for code. Wow, I don't write a lot of code, do I? This can't be right. Add statement. There we are. It's not just add code. It's add statement because that does the... Okay, I understand what you're doing. Yeah. Okay, let's put these back. Probably get rid of the semicolons too because statement implies semicolon. That's what's wrong. There we go. Oops. Is there a more specialized, like return? No. Yeah, there we go. New line, semicolons. I don't need to write any semicolons. It does it all for me. Okay. So the boilerplate's in place. He's got this damn bind method that we need to populate. Create elements. That should be easy enough to say how do you create these. And in fact, we've already got our two-string version, which is going to go through and do that. It's mostly going to be just the structural, hey, how do I walk this? How do I keep track of the name of the element above me? I'm worried I might end up building a class for every, or just about a class for every parsed type. I mean, I know we're going to need to do some mapping to say, hey, here's an expression. This expression consists of, you wrote a literal here and you wrote a reference here. So let's rewrite the reference to have some actual types in it. Things like that. Hey there. Vrutagel? Oh boy. Vrug T. Hagel. I'm very sorry for my attempt at your name. I'm going to go with that, though, unless you give me some more guidance here. I'm going to leave just a marker in here because we're going to have to do the unbinding later on because we haven't even thought about how to unbind old stuff. We put a little bit of thought into it. What are we building? Very roughly, we are making a way of doing... Let's see, this is the same class on both sides. That's not helpful. HTML templates in Java. This is already what IntelliJ gives us for free by using Java 17, where you can do triple quote and just say, hey, I want to put a big chunk here. And then by putting this annotation, IntelliJ says, oh, we're writing Java, or writing HTML, got it. And then it can autocomplete and give us other nice stuff here. The next piece is we have built our own MVVM using some view model stuff. So we've got observable properties. So for example, I can make a model kind of bean-like, which has properties on it. Now, probably this would actually have a bean that generated it, since this is so simple, if you just had a plain bean with getters and setters. But by virtue of being a property instead of just a string itself, you can say, hey, SKU, let me know when this changes, and then look for your SKUs in this list. So this li is in a UL, and the UL then is repeated over all the various items. And so if any SKU changes, it can modify the HTML content. So kind of think like, React or Lit or Angular, where you can say, hey, I've got some data here and I've got a template here, except we are writing the code generation today. I've been building this language over quite a long time. The language file is not there. Here, where we specify, okay, here's how HTML and XML already work. Documents have tags. As a top-level tag, tags are either elements or components, because these components are designed to be nested. And then they have attributes, and there's some kind of a notion about elements. Well, we're thinking about building a framework. Right now, it is definitely not meant to be a framework. Right now, it's definitely meant to be a library you can use and code generation you can use to say, I want to build individual things. One of my big complaints about React, despite the fact I don't use React and I don't really understand it very deeply, is that it has to own the entire world. It's just, hands off, mine, nobody else can touch it. Nobody else can really participate very well. And yes, I understand there's some web component stuff that's on its way that will make some of that better. But in order for it to do its job really well, it needs to have total and complete ownership. So the first piece here is a little more hands-off ownership, allow us to mix and match different libraries to build your own components. Oh, it's already here? They finally, web components in React? I mean, I know what web components are and that they already exist. They're kind of shit, to be frank. But as a spec, as a way to do interop, at least if you care about the compiled size. Because that's the next piece here. Oh yeah, I know web components are here. Yeah, I mean, we've used those before. But in React specifically is what I'm talking about. Whether React can get along nicely with web components. You can sort of fake it a little bit. There's a bunch of tools out there that will sort of kind of take a web component and wrap it up. I'm sorry, take a React component and wrap it up and make it usable, and vice versa. Say, hey, I've got this web component thing. Would you please use it nicely? And React will pretty much always, when you start changing things, just totally wipe the DOM out and start over fresh. So any kind of state that your component intended to keep just gets blown away. Which is okay if you're writing everything like React, as long as React owns the entire universe. But as soon as you try to stick something in there, like a reusable canvas or map element that needs to cache content, something where state really matters, and it needs to be kept out of React's universe, things break pretty badly. Or at least performance gets not so good. Plus, I mean, the whole VDOM idea anyway is how do we let you pretend to do something expensive and then make it actually not be quite as miserably expensive? No, that's really not true, unfortunately. Because that is true up to a point. Yes, they would not mind being there, but they're going to be slow. Because when React decides it's time to just repaint the whole thing and make a new element instead of modifying existing attributes, that's where the pain starts. If you have any cost to rebuilding where you assume that the VDOM will actually work and not repaint you from scratch every single time, that's when things get nasty. We have tried this. We put some... It does do that. Yes, it does sometimes do that. The trick is, can it understand the context well enough to understand, to recognize that it does not need to replace the element, but can just modify attributes? And that is sort of up to its internal magic for what's the heuristic for, should I replace this? Should I just try and tweak various things? For example, if you got a list of things, you can't always tell, if you haven't given them keys, right? Do I replace just the whole thing every time anything changes? Do I wipe out the whole thing? Or do I say, well, okay, this looks like the same data as last time because I'm the state manager, right? Ostensibly, I'm tracking state. No, we're just going to wipe it out. Just do the whole thing from scratch. So the premise here is that instead of assuming that there's any kind of VDOM where you should just always build HTML from scratch, you can assume, for the purposes of writing this HTML, that it's stateless, and it will reapply the state and functionally do what a VDOM would do, where this will always be accurate and correct. But because we're writing in Java, we've got a compiler. And we've got tools we can go through and we can analyze this and build it ahead of time. This is what Vue used to do. I don't know why they dropped it. But Vue used to have, hey, let's do everything up front as much as possible. And now they're pushing a little more stuff to runtime. I don't understand the ins and outs of that, so I would be happy to be taught. Yeah, right. So push me ahead here. So React, if you have components, the components are tagged down here to say, hey, here's the strong type that's going to define this. So here's the template that will build that. But then we've also got bindings, which we're also calling directives. They're kind of shaped sort of like React hooks to say that's how that should work. And repeat contents is sort of the most complex one we've got for this. It's quite a bit of code to go through the work of this collection here, items, is part of my view. My view is generic on ordered view model, which has items. So the compiler is first of all going to type check that, make sure that this is a list, an observable list of some kind, that it could go over to repeat contents. And repeat contents will say, here's your init. We're going to give it some, is it here? Yeah, observable. It's going to say it's some kind of observable property of some kind of list. It won't understand what exactly to do with this, just the code here, because of course you don't handwrite this repeat contents every single time. So the generics take care of that piece for you. But basically they say, okay, this is going to match the right kind of type. And this items then gets passed into repeat contents, which now owns these contents here. And it's its responsibility to iterate on startup and say how many items are there, repeat this DOM and apply these patterns for each of the items in items. And index and length are sort of magic properties to say, okay, it's a list. You can get your current position and the total length. So whenever anyone adds a new item to the list, it will paint a new item automatically, of course. It will also modify length on all the existing ones, and it will rebuild those existing ones. But only rebuild that one property. It shouldn't rewrite the entire thing every time. If you insert a new item at the top, everyone else's index will need to be shifted. So you've got 0, 1, 2, 3, 4. It'll push it down, so you've got 0, 1, 2, 3, 4, 5. How does it know what to rewrite? And that is the bookkeeping that repeat contents itself has to do in order to manage this. This looks a little like Knockout, how Knockout eventually did all this. It would need to redo the whole li text content. Actually, no. We found out that you can actually append text nodes, and those text nodes can have their contents rewritten as we go. So basically, we have one method that works on startup. We say when you init it, replace your children. We will bind your collection right away, and then we'll say your observable, we will listen to it and say, when do I need to replace and rebind your children as things happen. And then we'll go through the changes that happen, and we'll say if there's additions, we're going to append new things and wrap them in contexts and add them to our context tracking to say, hey, what should this have been last time, and then which range of the DOM was affected by this. Removal will say, okay, grab the existing context between first and last, remove them, and modification will replace in here. Now, keep in mind, this is just for the list itself. If you modify an item inside an item of the list, or if you just modify a property of the list, this will never notice. It's only if you replace an item that this will go off, or remove an item that this will go off, or add an item that this will go off. To go deeper into that is no longer repeat content's problem. It is now up to the code gen that said, if I have, this is the handwritten implementation, if I have a template like this and I am bound to some particular object, some item in the list, plus this other context, how do I figure it out? And we have a fake item that wraps that, because item is not, it's not a magical word or anything. It doesn't mean anything. There's no magic. That's one of the big goals. No magic at all. Here we have this loop item scope, which says I am myself a view model. I have an item, which will be this t, whatever it is, and then index and length come from here too. So there's no magic. It's all code somewhere. The code gen just has to figure it out and apply it. The item itself is where you might have changed something, and if you replace that, then we'll know about it, and if you change the value, we'll know about it. Okay, so how do you actually rewrite those things here? So now this is the part we don't have implemented fully. Here is the code. Here's the manually written code gen that would have done this. I'm going to pull them side by side, so it's a little bit easier to follow back and forth. So we built our outer div, right? That gets added easily. It's got a tab panel in it that's got tab position top set. That's easy enough to figure out. Line items get added next. And then once we get to the UL is where it gets a little more complicated. It's kind of magic. I mean, yeah, exactly. We're generating the code that parses this. I've already got that done. Next, we're taking the parsed structure and emitting code like this. But it should be very obvious every step of the way that what gets built. So bound directive of has scope means you are doing something here that happens to introduce a new scope. The new scope is created by repeat contents. Repeat contents implements has scope. And it tells you up front, if I am generic on foo, then I will create a new scope of loop item scope of foo. And so the type system Java has already solved for us what each item happens to be, and it will figure this out. So this is all obvious once you just stick the bits in here. So this is auto-generated from the word items. This is generated from the fact that you used repeat contents here and you declared it as a directive. That's easy enough. And then this lambda here is what do I do whenever there's something new to render? That way repeat contents can go through and build it and attach to whatever the new scope is. And value is, we can see it's a loop item scope of whatever the thing is. The scope is the children. Well, it's not quite the child. It is the child wrapper that we just looked at in repeat contents, which says I will hold the child, certainly, but I also have the index and the length, because those are interesting properties of a list. You might need context, extra context that gets added in your new scope that's introduced. So you can say item.skew to read the skew property of whatever something an item was, You can say item to read the whole thing, or you can just access these directly. And then all of this junk here is, okay, well, what is this whole template here? We make some literals, some string literals, and then this bound text node is the tiny bit of glue to say, make a new text node, and in HTML DOM element, it'll handle that. And then we add a listener to whatever the property was. So every time that property changes, it will call node.setTextContent on whatever the new value happened to be. And that way, this little piece here is keeping track of that. The one piece we don't have wired up is, how do you stop listening? When is it time to stop listening here? And we do have some weak ref things that will allow you to do bookkeeping automatically, but you don't want to rely on weak references to keep your performance under control. So we're expecting handling that separately. So if you change item.skew, right. So somewhere in here, we've implemented view, which says I can now call setViewModel. And if you held a reference to your view model and said, okay, I've got an item, and inside of that item, I call skew.set, right? So skew, let's put it in brackets. That way we can actually type here and get autocomplete. You could replace the set like this from anywhere else in your program. You could grab one of these. And by virtue of calling this skew.set, it's going to let your bound text node listener go off, which will replace the contents in that node. And we called this of from here, so it's going to replace the contents there. Garbage, well, okay, so that's the bit that we've completely missed for this discussion over here. Does Java not do garbage collection itself? It certainly does. We are actually planning on running this on a server, so that way you can do your templating on the server very easily. We also use GWT, which is hey, take all this Java code, which is like, TypeScript as types. And it's like, okay, yeah, you do an okay job there. Java has real types. We can run actual compilers on it and actually run it down to what is the actual code you need. How can we rewrite your code as aggressively as possible? We're using Google's Clojure compiler also for Jackal, which is a new Google tool, to also do the same work, to get much more tight optimization out of all of this. Item.skew, well, no, it can't work because skew is not a string, it's a string property. So it would be invalid to say something like this. That wouldn't compile. You'd instead have to call a method on here to say replace the value with this. You could also replace the model itself, and that would work. But you can't replace skew with a new property because nothing would be listening to that. So this is, if you use Knockout, it's similar in that way. So anyway, Java versus JavaScript both have a good garbage collector. Yes, that's true. Both have immutable strings, so semantics are almost exactly the same for what needs to be garbage collected. But the problem is, as soon as you start relying for your business logic on weak refs and keeping track of things that way, you run the risk of still doing calculations about objects that might be garbage collected. It's better just to aggressively say, no, stop the collection, or stop the computation because it's no longer referenced, and then let garbage collection clean it up. It's kind of dangerous performance-wise to rely on garbage collection to stop you from getting work done. So yes, this is a little bit foreign to most Java developers. You would want to have some kind of a bean instead, but we can build a Java bean or something that looks like a bean that extends and wraps from this and provides you getters and setters. And the getters and setters would just assign this property using the set calls. Set skew could just call this. And that is somebody else's problem, right? Because this is a library and it's meant to say, if you give me full information and visibility into your model, I can solve it all for you. If you would rather do a whole bunch of little mutations and change your bean and build it up and then give me the whole thing at once, that's what this setter method here is for. Just to say, here's a new view model, rework the whole thing, map my bean into a view model, and then pass everything out that way. And if you want to wait and get the full view model when the user's done, like after they click save, you can wait for that and then process things back in again. But if you want the visibility and if you want the ability to say, the UI just called set on this skew here, I want to know immediately and react to it. Now you need to actually opt in for the rest of the view model here, and in your own code say skew add listener, and then do something with whatever that event is, and handle that change and propagate it to your server, propagate it to the rest of your model, etc. So that's the basic idea, to say you can opt into as much or as little as you want. This is all written by my business partner in his own free time to say, how do we make this whole binding system work properly? And he's gotten all that working and tested. He's also building a styling system. That way it's a little like some of the precompiled CSS things out there, but to bind into these same properties, to try to use the same ideas and allow that when you create your own component, you can just set properties, and those properties will affect the styles directly. And I'm focusing on the HTML side. So I haven't touched this in like 6 months, so I've kind of forgotten what all needs to happen here. The code generation part right now can only do very, very simple things. So this is the manually generated junk here. I've got the boilerplate working in this generated piece here, and that's all it does so far, just the boilerplate. So the next piece is I need to dig in and walk through the model as it's constructed and build all these different methods here, all these different pieces here, and say, here's where you append contents, here's where you actually construct elements, things like that. Yeah, no, absolutely, it is scary. There are some use cases where it is pretty vital. One of the cool ones that he's been working on, and if you look at last week's stream, I think he talks about it a little bit, last Friday. He did a live grid where you can render 1 million items. And you can even have them in memory on the client, you just don't want to have them in the DOM. But the problem is when you need to modify the width of something, if you're not using actual HTML tables, you have to basically iterate through and modify the width of each of those elements to say each one of you is now 35 pixels wide, 35 pixels wide, 35 pixels wide, and that's expensive. But the use of dynamic CSS where you say, hey, make a new CSS rule, inject it into a style tag, and give it some class name that will never be used again and isn't currently used now, and give it some new styles. That gives you the ability to say, okay, now I've rewritten this. Oh, wait, you've changed that now. Let's make sure to always remove those properties. Right, you can use custom properties, and that's great as long as the person who is writing the grid is also the person who's using the grid. But if you end up in cases where you don't want to necessarily understand the ins and outs of the HTML and CSS, if you are somewhere downstream of the person who actually understands how all of it goes together, that can be difficult. Or, for example, your grid was not originally designed to have live grid, or was not originally designed to have grouping columns, and each of those pieces needs some degree of abstraction. You can't assume that all these various plugins put together understand the ins and outs of every single other plugin in the system. So how do you make them abstract out enough of what they're trying to do? That way they are compatible with each other. Custom properties. You mean CSS variables? Because yes, that is probably true. But I'm not just talking about 2 different people, but potentially 2 different teams. 2 different teams at 2 different companies. Or 3 different teams, 2 of them at one company and 1 at another. Nothing's more annoying than having to use important. Yeah, well, if you're using important, you've already screwed up. Yes, absolutely. Yes, as long as it's some degree of abstraction and it can magically work its way through. But when you have a drag and drop feature for, I'm dragging this here, and then I added a new column because a new column appeared in the database model, and I am dynamically creating my columns. Yes, which is... So when I say inline, I possibly misspoke here. I'm not suggesting necessarily that you add style attributes directly to the element. I'm talking about actually injecting new style tags and injecting those tags with new string contents. That way they are specific to that one thing there. That way something like inline styles aren't needed. It has to be assumed that an inline style is not meant to be overridden, because otherwise, yeah, exactly, you'll go crazy. There'll be just too many crazy things where someone says, oh, important is the solution to this. And then you have one less team member because something very bad happened to that team member who used important everywhere. And they can't come to work anymore. Not that that's a thing that happens among developers. Yeah, most of the bad code I have to deal with is something I wrote years ago, and I can never find that jerk, me, in the past, and tell him off for doing such a terrible job. So the one fun bug we found today is I have a method that calls another method, right? And it has types, interface, subtype. But I reordered those in this diff so that now instead of types, interface, subtype, I made it into types, subtype, interface. I swapped the name and order of these. And so it doesn't work anymore. So I need to go back 6 years and kick myself. Anyway. Right. So we have unfortunately done all of the boring boilerplate work to generate the Java. Let's make this a little bigger, a little easier to read. I haven't handled the third possible implementation here, view of data, yet. So now we're down to do the hard part in the wrong way. So I don't have a meta model that reads from the template and builds up structure as we go. So we're going to need to build a visitor that is going to walk our document, our language model here and say, okay, I found a document. I need to assign it here. The one thing we can pretty much guarantee we do is we know that root is the starting point. And then we're going to need to keep track of any new variable we create, local variable, to avoid collisions with existing fields we've made, because we don't want collisions. So factory, we're going to use a lot. I don't want to preface it with this every time. View model and root. At least in Java, we don't need to worry about colliding method names and field names, because that's not a thing that can happen in Java. I don't, unfortunately, see a very straightforward way to say, given this element here, what should its name be in the generated code? We could try to do something like grab the label, or grab the first attribute, but I could imagine far too often that would be garbage like this, and having the string top be your tab panel seems silly. So I think I'm inclined to say we will just grab the tag name and then use that and then just stick a counter on it or something. And if we follow a pattern like that, where the counter is starts at 1 or starts at 0, and you always append it, then we can't even have collisions outside of here. So we just have to have a simple little tracker here. So I think all of this is going to live in here anyway. So we'll just make a method that generates this. And this will be something like generate bind method. Or how? You have div 73, and that's true, but remember how custom elements work in the browser, that they need to have some other way of denoting that it's a custom element. So you can't make a custom element div 7. That's not a thing. It has to be custom element div -7. So we can already notice you're doing silly things like that. And probably just because of how identifiers work in Java and JavaScript, we'll replace dashes with underscores. Make a component div. No, all of your custom elements must always have a dash in their name. The browser constrains this. It says that if you call define element, you make a component div. What do you mean then a component div? Like a custom component? Tab item is when you say, I have passed into the component here, I have said this is a class called tab item, right? So first of all, it has to be capitalized, which is not allowed for custom elements or regular DOM elements. And you can't have collisions in two different tab items. You cannot name those. I mean, no, the language will not permit you to. The language says if it's capitalized, it's a component. If it's lowercase, it's a DOM element. Because we have to behave differently around them in order to... yeah, they are, but HTML tags also don't have to have closing tags. But if you don't put a closing tag, for example, React will slap your hand and say, put a closing tag, because I won't parse your content. So we're in pretty good company saying you have to follow some particular conventions. Otherwise, someone's going to go crazy at some point. We have to have some way of saying our language is actually not quite HTML. For example, how do we denote event handling? We're not going to do JavaScript : junk in here or something like that. So right now we've got the @ is going to say, I'm going to hook up to some kind of an element event handler, and we're going to do the wiring after clone time, because you can't clone those things. Yeah, exactly. We had a whole bunch of documents open that we're trying to take apart why other tooling does the things it does. Like, I understand why React cheats and lies to you about exactly how the event model works, but it's very frustrating when you actually know how the event model works and you try to hook things up and then things don't work properly. And likewise, if you have a HTML element, but you put a capitalized thing in it, we are going to assume that it is a directive, binding. And again, binding versus directive. Why not just onClick? How do you make sure that nobody ever writes a HTML web component that uses an attribute called onClick? So we can't be sure of that. And it is much easier to guarantee that by just having a language shift here and just say this now has particular meaning in how we build this. OnClick is a global attribute. It is also technically an attribute on every DOM element. Is it global? If it's global, it's only because a window itself is an OnClick to it. Element has it. Does window have it? Let's poke here and see. It does have it. Okay, so this is going to be just an event handler. Right. So what's the question? I mean, it is technically an attribute, but we don't want to pass strings in there. If the system were to say document.body.get attribute onClick, right? That's going to be null. If I say document body onClick equals console.log, that way I can do fun things like, hey, look, it's working. It's still null attribute. But I'm transpiling it anyway. Right, but the question is what happens if someone actually wanted to set an attribute because they have my magic web component that has, because they're jerks, they have onClick equals an actual thing in here. I don't want to have to keep track of how do I tell when it's a click and when it's not a click, right? I mean, how else would you know that if they want to set that attribute, it's because they want code to run on click? Are you sure? Can you guarantee that no one will ever write stupid HTML ever? Because I have bad news for you about the internet. @click is saying this isn't valid, so it's not going to be an attribute. My experience has taught me never to underestimate what some jackass JavaScript developer has done out there because they thought they were clever. From the birth of Scriptaculous onward, I have been dealing with I'll just monkey patch array or element or window. What could go wrong by adding new attributes to other people's objects? So I don't think it's safe to make assumptions like that. Let's see, generate bind for, and then we're in the actual implementation for hasDOM. Eventually we'll abstract this out to be some kind of allow you to build your own thing. But I feel like having onClick instead of click would push people in the right direction. Yeah, except you're calling Java methods. We're not really calling JavaScript. But then again, it might be someone else that did it and you have no choice. You mean in their templates? If they add onClick and they expect to actually call JavaScript? I mean, even my IDE is trying to say onClick, hey, you can actually stick JavaScript in here. Look at this. That log event, this, because I guess that's the element itself. Even the IDE is trying to say, no, this is a valid and cool thing to do. These browsers are stupid. What doesn't do JavaScript? It wouldn't run JavaScript? No, why would I run JavaScript? It will eventually be JavaScript, but all this code here is Java until it isn't. It's not like because it's HTML. I mean, yes, but on the other hand, what do you want this to mean inside of here? Do you want it to be the button itself, or do you want it to have visibility into what the model is and what the component is? Odds are you want your click handlers, like add line item, to actually have access to your view model and manipulate them in some actually useful way. If all you get is this, you're not going to have access. Yes, that's what GWT or J2CL do. They have a way to say, hey, you've got Java. You can't use threading, you can't use reflection, you can't use I/O. But basically everything else, because, I mean, there's no threading, reflection is a bad idea in the browser. I mean, that's the basis of JavaScript, but it's still a bad idea. And you can't do direct I/O. But then you can have things that wrap the existing I/O, like fetch or like the file system access API. Oh yeah, so we take that for granted. That is the baseline for this conversation here, is is we start everything in Java and build things and say, okay, now that you compile these things. So basically, you just liked React so much that you decided to do the entire front end. No. GWT has been doing all the things that the JavaScript world, ES Next, is slowly reinventing them. We've been doing all this since 2005. You know, this chunk thing, this cool thing that came out a couple of years ago? What if we broke our files into multiple pieces and had the compiler figure out automatically how big they all are? Like, hi, it's 2007's calling. You know, Java's been able to do this in JavaScript forever. So little by little, you know, React and the rest of the JS world are reinventing what Java's had since IE6 was cool. And I really haven't found a compelling reason to say not to do it anymore. TypeScript is pretty fancy. Hey, Ahmed. TypeScript is pretty fancy for a lot of things it can do, but unfortunately, it also leaves a lot of room for how do you optimize this? There's no effective way to optimize a lot of the things that JavaScript can do. Now, Google does have T-SQL. Okay, then plain JavaScript is even worse, right? I mean, you can't optimize practically anything. T-SQL is a tool that Google has that will turn TypeScript into Clojure. Ostensibly, existing Clojure, if I can spell, this one here. Ostensibly, regular JavaScript can be optimized by the Clojure compiler, but you have to start off with strong, strict types. If you ever start saying, well, I'm just going to go ahead and make a new key in here using square braces and then reference it by a dot later on, this will just completely throw up its hands and say, nope, your code's crap. I can't do anything with it. And it won't work anymore. You can optimize JavaScript at least as, no, that's simply not true. TypeScript, TypeScript at least, okay, yes, you are absolutely correct. If you write TypeScript in the style of terrible JavaScript, then you reduce the capability of a hypothetical compiler. But TypeScript, by virtue of having type annotations, if the compiler can trust you, and maybe that's a problem here, but if the compiler can trust you that this will always be of a particular type, and that it can see the entire universe of what subclasses are even possible, it is able to go through and say, well, let me optimize these things out. In general, the average JavaScript project you pick will not be static typed enough to be able to do that. In general, TypeScript projects are. Now, obviously, you can write crap in any language. I can't dispute that. But the kind of code that TypeScript is going to generate, the kind of JavaScript, is at least somewhat more likely to be possible to be optimized. But anytime you have any kind of dynamism in your JavaScript, it's going to throw off a compiler, an optimizing compiler, a real one. I don't mean like ES Next and the fun toys we've got there, but something like Clojure compiler that will go through and rebuild at very fundamental levels what your code even does. Do you happen to know how much that difference is really? Well, let me tell you this. The Java that we build, up until the last time I was checking benchmarks, handwritten, idiomatic Java ends up being 10% faster than similar idiomatic JavaScript. Just by taking the same code, transpiling it into JavaScript, and then being able to say, now I'm going to guarantee that you're following Java rules here because it started off as Java, and then optimize the crap out of it. So Clojure compiler does not actually optimize for performance, it optimizes for code size. However, that almost always ends up meaning performance. There are a handful of places where they say, let's make it slightly smaller because Google, of course, cares about the scale of bandwidth, things like that. But given the choice, if they have a some kind of a cutoff there, they're often going to say, well, what if we just made it a little bit smaller instead of faster? Because smaller is going to mean faster. They parse faster. Yep, exactly. Yep, and they send faster and they parse faster. Yep. So they want to worry more about how do we not just tree shake, but how do we actually optimize? Because tree shaking is like the simplest, kindergarten version of, okay, this type doesn't actually reference that type. That type go away now. But to say, okay, well, you only call this method from one place and you called it with this argument. Okay, so we're actually going to rewrite your call site to have no arguments and put the argument as a local variable in the method you called. And then, well, now we can say that since locally it has this value only, we can rewrite any ifs or for loops, or maybe we can even make it a const in the class itself, or just inline its value everywhere you happen to use it. There's no need to even have variables, and so on and so on and so on. And there's just if you go into how Clojure compiler works, you can find there's this whole range of passes. I would have to spend a little time looking because I'm not as familiar with where they keep their passes. Parsing modules, regex resources. I need to actually open the project, which I have open around here somewhere. Let's see, open. Maybe I don't have it open today. Here it is. So it assumes it's in its own bubble. Yes, you can poke holes in the bubble. You can say, hey, these types here are defined externally, like the browser. You can't ever assume that you own the entire universe if you are calling into browser functions like create a new uint8 array or document.createElement. You have to define what the contracts are you have with the outside world, and likewise, you have to define the contracts that you establish for the outside world. So if you provide a constructor call or some setters and getters or methods that can be invoked in JavaScript, you have to say, hey, here are the things I export. Here are the symbols that must not be mangled when you change these things. And the compiler is going to look at those and it's going to get grumpy and say, but now I can't optimize this. And you say, that's the point. So you want to keep those as small as possible to avoid any other headaches along the way. But yes, those are the ways you poke your finger through the bubble and say, okay, now I can live outside of my bubble. I can talk to things that are outside. I can behave as if I'm not the only thing in the universe. But the more things you bring into the bubble, the better it can optimize, because the fewer things it is told you may never change anything about this contract, the better it'll be able to do its work. So like, let's look for compiler pass. So this is a giant class that goes through and lists all sorts of different compiler passes. If the bubble has no holes, the compiler, yes, it loves it. It's fantastic. So either you just call one of your own functions, like, hey, you're an application. Once the application gets on the page, run your start method, and then go ahead and start building things. And it can just do whatever it wants. But if you don't even have that, the compiler is just going to work its way through and say, yeah, here's an empty file. Congratulations, you did nothing. And it's very happy to do that. So here's a list. This class has just all the possible optimizations, when they might need to take place, how they're going to be configured based on your other arguments. A lot of this is designed to be called from the command line, because they built a command line runner. Some of our tooling has gotten to the point, though, where they don't parameterize everything that we need. So we have stopped actually calling the command line runner directly, and we just build an instance of the compiler, and we build our own pass configs to say, you know, here's a special pass I need you to do to optimize something. And every once in a while in here, they do have, hey, here's the specific things about Jackal, because Jackal is a Google project. So somebody at Google had to go through and say, okay, strings from Java have these particular properties. Here is how you're going to rewrite them to, as efficiently as possible, say, instead of doing these Java calls, we'll make them closer to JavaScript calls. If you just see undefined and someone happens to concatenate undefined into a string, just replace it with the letters null, because that's the expectation that the Java user originally had when they built this. There's actually a bug in here where it generates a little bit too much garbage. I just haven't had a chance to build it. But it's a very small performance optimization. It's not something anyone would likely notice. Okay, so code block is how we're going to build this here. We need to see what's over here. I'm getting hungry. I've got 20 minutes to get to the bus stop for pickup. We need some more parameters here. This isn't going to work with no parameters. We need at least the document. We need the accessor that we will use to get access to the view model, so that we can say things like, let's see, where's view model highlighted here? Where do we access the first property? Oh, hit get view model here. So get view model.items is the first place we access in this example. Here we're showing that even inside of your new scope, you can actually say, okay, I'm inside a new scope, but I can reach outside of my scope and access the root view model, which is kind of a funny use case, but I know it happens. And so that's why we made sure to add it. Recipient is part of the outer view model. It's not part of the item. So eventually, we're going to need some kind of a property resolver that'll say, I have this item here, and I can access item, index, and length. And recipient is not one of those things. So I have to hop out of the current scope. And we might have scopes nested within scopes and so on. So we're going to need a way to peek up the stack and find how deep you are in there. Which tells me that view model accessor and type, view model type, are not going to be enough by themselves. And we are again bumping into colon, give up, make a meta model here that will describe all this. Because I want to pair my view model descriptor and my view model type together and say, here is how we're going to build those. Let's make a quick class here for that. I'll make it private for now. Come on, fingers. So what do we call this? Like view model reference? So we'll just pop one of these in here instead. Except I'm going to want an array. Well, but I don't want a proper array. I'm going to want actually a stack. So I can pop them as I go. Stack, there we go. Because there will just be one thing. And probably I want my own stack type for this, because I want to be able to resolve it without actually doing my own iterating. So let's make it a view model reference stack. Stack, no aren't stack. We'll make it a reference stack. Let's make a new class for that. Now in this case, we're going to say, am I looking up by item, length, index, recipient? So we want to have a key that we look up with. So we have a key. We're not going to be actually returning a string. We're going to be returning our view model reference. Is that with Jackal or is that with Gwt 2? Because I believe it's even smaller if you use Gwt 2, because we don't have locales working nicely in Jackal yet. That's Gwt 2. Okay, okay. So what do you consider a real project? How big is a real project for you? This is a sample project that's meant to say, hey, here's how big these things need to actually get. Really? You've never run a JavaScript project that's a megabyte in size? You've never run a JavaScript project that's... So let's pretend that JavaScript is twice as expressive as Java. You've never run one that's 60,000 lines of code? And actual lines of code. I don't mean comments in white space. Because there are... I mean, Inbox is... You know how big Gmail is. Oh, is Gmail well written? I'm not going to open up my Gmail here, but I'll open up Sheets real quick. Is Sheets well written? Sheets and Gmail, the engine on both sides, not the UI, the engine itself uses this Java to JavaScript compiler. Oh, come on. Let me use DevTools, you jerk. More tools. DevTools. Let's go ahead and clear it. No cache. So I'll bet this is 8 megabytes. Oh, no, I'm wrong. There's a lot of features in a solid enterprise project. I mean, if you're just baking your CRUD app, I'm not really interested in how do we make that better. Because absolutely you should use plain JavaScript and React for a simple CRUD app. Here we go. 31 megabytes downloaded, 11 megabytes over the wire. Let's restrict it to just JavaScript to ignore the other stuff. 19 megabytes, 5 megabytes. Yeah, I don't think that's terribly unreasonable. This is for all their various charting, assistant, code editors. They're all reasonably sized by themselves, each individual file. Nothing's over a megabyte that I see so far. Let's just sort it here. 1 megabyte. Okay, so this one's pretty big. Waffle.js, whatever the heck that is. Here's almost a megabyte. So there's an edit and a core, and a calc worker with J to CL. They put Jackal right in the name. Response has been truncated. Yeah, it's a little big, isn't it? Well, this is with split points. Why do you think there's so many files? This is with it picking up split points, and the Clojure compiler is able to generate those too. Oh, sorry, that's Ahmed saying that. Yeah, I mean, the project I work on by day, which is all available on. Actually, can I do this here? Yeah, this demo should work. I don't have the project running locally. Oops. Is that the wrong URL for this? I haven't done this in a while. Oh, .app, sorry. 1 megabyte is not all that much. It's 1 megabyte was a lot in, I don't know, 2015. That's table stakes for enterprise projects. So this is a React project. This is all React. The JS API is designed in GWT, and the gRPC code is all from Webpack. Just plain old Webpack saying run the gRPC in flat buffer code. Let's look at the network call. If we just look at JavaScript, DH internal, so this is just running plain Webpack. It generates 1.15 megabytes. 2 megabytes for the JS API. Now that is unobfuscated and unoptimized because we want to make it easy to debug, but we can turn that on. And then this is the Monaco editor, right? You've used GitHub before, I'm sure. The Monaco editor is 3 megabytes on its own, and that is only with Python and Groovy support in there. We don't have all the other random languages they support. Vendor is dependencies that they're pulling in. The app itself is 1 megabyte. 3 megabytes. I guess there's another copy of Monaco. That seems silly, but whatever. Who am I to argue with Webpack? Webpack is the be-all and end-all of possible ways to build things, of course. It looks like it loaded twice. I'm guessing these are actually only one copy here. Yeah, exactly. Oh, that's... Yeah, I don't know. I haven't seen a lot of React projects that are under a megabyte. Sure, but that's the point, that the app is much bigger than that. Even for individual chunks, they have to be bigger than that. There's no opportunity to make them smaller. Except just to say, well, what if we made it into tiny, tiny pieces and made you download a whole bunch of them? But that server is all using HTTP2 because we need it for streaming content. Because the point of that project is rapid streaming content into the browser, real-time content. So we're already using HTTP2 for that anyway. You're not going to get better bandwidth by just splitting up to more connections because you've only got one. You can try that. If you would like your applications to be blog posts, I think you've got a decent case to make for that. If you don't want to get beyond blog posts with comments on them. But if you need, I mean, I didn't show what this thing here is. This tool is. This is a tool that's used for real-time. Exactly. Barely any. I think a blog post reasonably, if they had 5,000 lines of JavaScript, I wouldn't give them a hard time for it. Let's grab one of these things here that actually does something. Can I just run this thing? Is this going to all build out properly? Is it going to run the whole thing? Or do I need to go through and build each one? Okay. So this is an IDE that lets you run Python. It doesn't run the Python in the browser. It all runs on the server. Let's see here. Did it actually execute that? Okay, I've got a def now for this. Can I just click through and run each one automatically? Oh yeah, I can. Cool. I haven't used these demos in forever. Here's where it's going to get expensive. I probably missed a step earlier on. Invalid syntax, line not available. Yeah, smaller is better when possible. Right, of course. Exactly. If you say apps, I would not be surprised if a downloaded app is hundreds of megabytes. Okay, let's try for 50. Keep it under 50. 10 would be nice. But when you live in a browser, you're so limited in what you can do anyway. You've got to reinvent everything anyway because there's no good way to do, like, autocomplete. We have to reinvent that, to say this is ag ring dot whatever, and then get autocomplete to. Okay, the autocomplete is. What version are we running here? The autocomplete should work on there. This must be an old build. 19.1, that should have good autocomplete. I wonder what happened. What's your problem? Oh, aggroing is not defined. Okay, that's why autocomplete didn't work. Because it didn't exist. Let's try latest offset. There we go. So you wouldn't say it's hard. Right, exactly. Each one of these little tiny pieces by itself can be done simply. But when you need it to be done generically and flexibly enough for everything that this can do here, and we're only seeing single cells, so these look silly in how simple they are, because I ran some command out of order. I broke it. Latest offset is get trades. This one will do a last buy here. Partitioning. There should be something more in this one, shouldn't there? Listens to current records, crypto trades happening right now. I don't know anything about Kafka or crypto. I just know how to run the code. What if we just kill all this and try one of these other ones? There we go. We got data coming in now. Actual data. So this is a grid that's made to handle a billion rows in the UI. Without exaggeration, a billion rows. A trillion works. It can handle a trillion. It doesn't like having more than 1,000 columns, but without exaggeration, it is capable of doing that. And then each of these other pieces here are just how do we have enough continuity client to server to keep track of all the state, all these different objects we've got open on the client, and still have them be ticking and have their data coming in as changes happen. Right now it's configured for only 1 update per second. That's configurable though. We don't ship it out of the box doing more than that. So each one of these subsequent things here is building a new query on the fly that is doing, joining or filtering or adding custom columns to say what should these be here. And this is comparing, time by time what the relative price is between, I guess, Ethereum and Bitcoin. I guess that's what this is. But it's done by joining these things together, those various other ticking tables in real time with each other, and then pumping those updates to the client. This is, yes, you can individually build any one of these with dozens of lines of JavaScript. No question. But to be able to take all of this then and say, okay, well, we need to actually allow you to drill down into whatever work you happen to be doing that's important. The time should be the same. We'll put 2 series for price, and we'll do another one for ratio, and let that be lines, and synchronize it. I guess the scales are so far apart that it's not really going to be very helpful to do this. This is also naturally, it's only 1,000 lines, so that's easy. Until you get up to 30,000 lines or so, it's not gonna have any problems. But performance will be a problem with more than 30,000 rows being pulled down. Well, I think it is fair to say that, and in fact, that's why I use Java, because I 100% of the time say, yes, those applications are too big. They could have optimized their code, but they wrote their code in JavaScript, so they decided not to optimize their code. And so the premise here is, okay, we've got strong types, let's use them and make sure to optimize out the pieces we need. If we're going to quibble about, size, there's usually more DOM elements that are necessary. You could just write good JavaScript. Yeah, I spent a couple years doing that. And in fact, I thought it was pretty stupid to use something like GWT at the time. And then I moved to a team which I had to corral a dozen developers and get them to write good JavaScript, and get every single one of them to write good JavaScript, because this was a 250,000 line application, just the client side, and getting all of them to pull the same direction and never waste DOM elements and never waste how big their function is, and always go through and say, oh, this function is only called in one place, I should inline it instead, because I am costing at least the word function to define a new function somewhere else in the application, not to mention curly braces and parentheses instead of just inlining it. Because you have to tell people, never factor things out for reuse if you want to be writing optimized JavaScript. If you want to rely on a compiler, okay, then you have to give up all these other things. Like, at the time, you can never use jQuery. jQuery used to be the thing that people wrote when they finally got off of Scriptaculous and Prototype. But as a language, it ties your hands too much for what is possible to refactor and how quickly you can go back and clean things out. If you can just feed the whole thing into the wood chipper that is a compiler and have it take it apart and say, okay, what you meant was this. We're going to go ahead and rip the rest of this out. Or you only called this in one place. I'm not going to make you refactor it. I'll just do it for you. Yes, you can write good JavaScript yourself. You cannot scale your good JavaScript writing ability to managing a team of more than, I'm going to say 4 people, because that's my experience. We got to 50,000 lines and 4 people on a smaller team, and we could consistently write good code and efficient code and compile it out with just simple tools. But as soon as we ever added a new person, that new person, we would be integrated into the team, but we weren't able to keep enough knowledge in all of our heads about what the other people were doing and how to always avoid reuse and maintain consistent design patterns to keep everyone relevant. So we inevitably ended up bumping somebody off the team and saying, wouldn't it make more sense if you worked over there instead? Sorry, I need to look at this because it's almost time to go. Get the bus. So I don't disagree that small applications that you can build in 6 months, absolutely fine. Maintain your project over 12 years and come back. Keeping your team of 4 people, never letting anybody leave and come back, or new people join on, or need to grow faster than you can get 3 people to grow. I completely disagree with that premise. I think it's impossible, unless you have people that don't sleep or something like that, which is a whole different kind of, your tools are so wrong that your tools are probably wrong because your culture is wrong, and it's catastrophic. Yeah, again, I have not seen long-lived. There's too many long-lived projects that are not long-lived projects that are not long-lived because they rewrite to solve their problems, to solve their, well, this could be more efficient, so we'll just rewrite it. We should be able to do this efficiently in Java or in JavaScript, in just plain JavaScript. So we'll just rewrite it. Let's see. All right, I really need to go. I will be back. Probably not today. We're probably back next week. I think Justin's gonna be back on Friday to continue up on his work. This is just, if you were wondering about this, this is not visible yet to the world. I need to get a little further here, and then we'll be at a point where we can turn on a regular project and see how things are looking. And once we get to that point, we'll start opening this up to be visible. So anyway, I gotta go. Thanks for hanging out. I appreciate your willingness to disagree and at least consider that there's a chance that I might have a useful perspective here. Anyway, have a good one.